Ah. Sir, I think now the speaker has also joined, and I think now we'll.
Sir, வந்துட்டாருங்களா?
Kaylee, if they are able to see the screen.
Okay. Yes, sir. I think now we can officially commence the session. We'll hand over the platform to the Department of Statistics. Madam Jayashree, please take over, madam.
Good morning, sir. Good morning, all.
Just a minute. Can you see the screen?
Yes, sir.
Yes, sir. Yes, sir.
Okay.
Shall I start?
AC put.
Good morning. A very warm welcome to all the participants.
Yeah, sure.
Are you able to? Shall I start, sir? Hello?
Yes, madam, you can proceed.
Yes. Good morning. A warm welcome to all the participants and the resource person. There is a small change in our agenda. Professor Martin sir will be joining us in the third session, and Professor PonnuRaja will be there for the second session today. And we'll start our sessions with the great statistician and researcher, Professor M.R. Srinivasan sir. He is a retired professor from Department of Statistics, University of Madras, and he is also a guru to me. And I invite Professor Renuka Devi to welcome Professor Srinivasan sir. Professor Renuka Devi is there?
Yes, yes.
So I hand over the session to Professor Renuka Devi. Thank you.
Thank you. Is it audible?
Yes, 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 ma'am. You can start.
Okay. Good morning. Our speaker this morning is well known to many of us. It's my great pleasure to welcome the speaker of this session, Dr. M.R. Srinivasan sir, retired professor and head Department of Statistics, University of Madras, to the webinar on statistical modeling for high dimension data. I feel elated to introduce our speaker, so my guide, Dr. M.R. Srinivasan sir. Sir's career has taken him through more than 3 decades of study, research, teaching, and administration. He took up his both UG and PG degrees from Osmania University, MBA and PhD from University of Madras. He served as assistant professor, associate professor, and professor at Department of Statistics, University of Madras, Dean, College, Development Council and Academic, also Director, Curriculum Development Cell, University of Madras. He also served as member, Tamil Nadu Backward Classes Commission, Government of Tamil Nadu. MRS sir guided 16 students for PhD degree in statistics, and he published 75 articles in national and international journals. M.R. Srinivasan sir has delivered invited talks in many national and international conferences. His other assignments include visiting scientist at University of Manchester, McMaster University, Canada, and University of Naples, Italy, assistant professor research at Washington University and University of Texas, USA, associate professor at ISI, Kolkata and Bangalore, professor at University of Dodoma, Tanzania. He served as chairman, Board of Studies in Statistics and Actual Science, University of Madras, member of Board of Studies in other universities, NAC Review Committee, UGC committees, various academic committees, University of Madras. He was also a member of Academic Council at various colleges and Tamil Nadu Account Statistics Commission, Government of Tamil Nadu. He is also a nominated member in International Statistical Institute, Netherlands. So it's my honor and privilege to invite Dr. MRS sir to give a talk on joint modeling in data analysis. Welcome, sir. So over to Dr. MRS, sir.
Yeah, can you hear me?
Yes, sir. Yes, sir.
Yeah. First of all, thanks to Professor Prakash, Professor Vishwanathan, Professor Venuka, Professor Jayashree, Sundaram, and other colleagues of Presidency College for having invited me to this webinar today. Indeed, it's a great pleasure for me to be a part of a presidency group. But as you could see from my slide here, that it is destiny that I couldn't meet you personally, but I have no control over destiny, but feeling bad about it because I am missing the tea, snacks, and lunch from Presidency College. Probably that's one thing that I am missing. And I couldn't see all of you in person and give a handshake, which I usually do when I visit Presidency College. But anyway, that apart, I'm happy that I am virtually meeting you all today through this webinar. And as you know, Dr. Renuka introduced me to the seminar. She had a tough time working with me for her PhD, and I think that is not there at the back of my mind when she introduced me to the audience today. So with these few words, I would like to continue with my talk today. Indeed, as all of you know, that most of my research work is basically data-driven. I'm not a theoretical person. I'm basically a person who works based on data, either real data or simulated data. So this particular talk, which I'm going to present today, is also a data-driven problem, which currently Gokul is working on. And hopefully by next month, a month after that, he will submit his synopsis also, because I think part of his work has already been published in journals like Data Science and Social Research, which is a Springer volume, Statistics and Computer Applications, and also Statistics and Applications, a European journal. I think publications have already been done, and hopefully in a month or so, he will submit his synopsis. So my idea here is to present the ideas behind this particular work, which I'm going to do over probably the next 45 minutes or so. But before I commence my talk, I have to give an idea about what prompted me to do this particular research work, or probably work with Gokul on this joint modeling. See, we had a project, and I was one of the collaborators with Dr. Swaminathan of the psychology department, which was a UGC-sponsored project on cognitive behavior. And we tried to discuss a lot on cognitive behavior and human intelligence, which is important for psychology. But of course, as all of you know, we are all more data-driven. And so we are very fond of data and we work on data. And so we worked on this particular problem. And so I brought in Gokul to be a part of this particular project. And Gokul worked in this project for probably a couple of years or so on cognitive behavior with me and Dr. Swaminathan. And so the outcome of whatever the research is going to be what I'm going to present today, and what is going to be a part of the thesis of Dr. Gokul shortly. Swaminathan has done a lot of work in cognitive behavior. So you could see that the work that I'm going to do, I'm going to present here, is going to be a part of this particular work. And you could see that what exactly the work is all going to be. And I just want to share with you an important aspect that Tamil Nadu is one of the pioneering states as far as noon meal scheme is concerned. But obviously all of us know that this noon meal scheme is driven more by many reasons. which are not statistically analyzed. But there are areas or domains where we are yet to explore. For instance, we started looking at giving eggs, giving fruits, giving milk, giving pulses, so on and so forth. But we have not looked into the aspect which one really helps in increasing or enhancing the intelligence of school students. Or is it possible to interchange the supplements from milk to fruits or fruits to pulses or whatever it is? So here an attempt is made to get data from a Kenyan study where they have done a systematic study. Systematic data is available, maybe thousands plus, and we try to analyze this particular data and look at the nutritional supplements and see how it enhances the human intelligence or whether it improves the human intelligence. That's what essentially the whole study is all about. So I will just go ahead with my talk. So you could see the overview consists of basically four different points. One is, as you know, this is not a cross-sectional study. This is basically a longitudinal study, very important. Second, what is the key objectives as far as this particular study is concerned? Third one is the data analysis, which is the crux of the particular project which Gokul worked on. And finally, the results and conclusion based on this particular data analysis or the whole study itself is what is going to be the last aspect of my study is all going to be. As far as you could see that the slide is, the longitudinal data analysis is very important. As all of you know, that one more student of mine, Mohan, also worked in a similar area of longitudinal data, where he tried to work on missing data, missing completely at random, missing at random, so on and so forth, and tried to build some models based on the longitudinal data. So here, studies in which individuals are measured repeatedly over a time period, collected based on repeated measurements, constitute the longitudinal data. So most of the studies, people try to look at the cross-sectional data, but invariably it's very important that we try to look at longitudinal data. And nowadays, when you talk about the big data and the real-time data, which people are very fond of, it's more a longitudinal data. And so it's very important that the analysis is based on longitudinal data because we can look at the pattern, which is very important rather than cross-sectional data, which we are all familiar with. And many of the scholars have worked are still working in the domain of cross-sectional data. Unlike the cross-sectional data, longitudinal data collected based on measurements will be useful to study the developing pattern of change. So that's very important as far as the cross-sectional data, longitudinal data is concerned. So obviously, we are more interested in looking at the cross-sectional, longitudinal data. And as you know, the important aspects which one needs to look at it as far as the longitudinal data, which is common even in cross-sectional data also, is the problem of correlation arising due to repeated measures. And the most important is the missing data points. And of course, as you know, I'm very, very fond of outliers because as you could see that about probably I think half a dozen of my doctoral students worked on outliers in multidimensional data, outliers in categorical data, outliers in design data, and so on and so forth. So obviously, I'm also interested in outlier aspect. And so obviously, when outliers are there, you are interested in having a sort of a robust models. So that also needs to be looked into. So all we are trying to look at it is a longitudinal data, not a cross-sectional data. We try to look at the correlation aspect, and we also look at how to work on when you have outliers. And of course, the last point, the missing data points have not been considered as far as this particular study is concerned. And of course, we are trying to look into that particular aspect also. Probably we can look at that at some later point of time. I'm sorry, I have to look at my slide also because a part of it is not visible to me. And please bear with me for that. So you can see the cognitive functions and intelligence, which I was talking about, wherein I had a collaboration with Dr. Swaminathan. You can see intelligence may be roughly defined as the ability to solve any problem ranging from verbal to non-verbal aspects, which includes numerical aspects, musical aspects. Probably many of them are not interested, or probably very few are interested in that aspect, bodily kinesthetic, etc., etc., etc. So there are very many aspects which goes into that, and probably many people are seriously looking into some of the verbal and non-verbal aspects only. Swaminathan was telling me that there are very many aspects which we need to look into as far as the human intelligence is concerned. The concept of intelligence has been explained theoretically based on several empirical research studies, wherein, as all of you know, factor analysis has been a very important aspect or important tool. And here, the psychological tool, psychological or psychostatistical tool or psychometrical tool is going to be the Spearman's two-factor theory of intelligence, which is known, well-known, and very popular as far as the psychological studies are concerned in cognitive aspects. Now you could see that there are two important factors which goes into it. One is the G factor, the other one is the S factor. The G factor, as you could see, is a general factor which is common to all human beings across culture. And to measure these, there is something called the Raven's progressive matrices tests, which are more reliable, and these are valid measures to measure the so-called G factor. So they are called as culture-free tests, and it can be done across all individuals or all subjects, and you don't have to worry about the gender, the color, so on and so forth. So the G factor is a sort of a common factor, and this is one measurement which the psychologists try to work on as a part of studying the human intelligence. So these tests are non-verbal in nature, and so there's no use of any language in any term. So obviously that's the reason why this particular factor is called as a general factor. The second factor is what is called the specific factor. So there are many things which goes into it, and these are varied in nature. As you can see that it could be linguistic in nature, where language comes into picture. It could be numerical, it could be musical, it could be bodily kinesthetic, right? And other abilities which are brought under the S factors, because these are more specific in their respective domain. So you could see there is something called a very general factor, which is going to be a general factor, which is measured across all people for the intelligence. And the second part is going to be the specific factor, which I think some people will look into the musical aspect, some people will look into the numerical aspect, some people will be looking into the bodily kinesthetic aesthetic aspect, so on and so forth. So obviously, when you talk about human intelligence, you have to look at both the G factor as well as S factor. So the psychologists are interested in both the aspects and not just a G factor or only S factor alone. So my objective as far as the psychological studies, as far as our study, which is the longitudinal in nature, these are basically made of to identify a suitable model for the longitudinal data with different random effects, and also examine the most important aspect why we have a joint model here. You can see that there's a G factor which is common to all of them. There's an S factor which is very specific in nature, and we would like to evolve a joint model of both G and S factor. So a general factor as well as one specific factor which is of intelligence, which is of one specific nature, in order to study the human intelligence. And so we are more interested in developing a joint model for a G and S factor. Obviously, when you develop models, you ought to look for influential observations in the data and adjust the same values by giving due weights. This is what is being done in a robust analysis. So you try to downweigh some of them, you try to upweigh some of them, and do that in order to get a robust modeling. And that is what is being done in order to get a robust model or a robust joint modeling, I would say. So you have to look at the association between G and S factors of human intelligence by fitting a robust joint model with, of course, you have the covariates also which are being considered, and that is going to be used in what is called as a school lunch intervention study, which was done in Kenya. Of course, I mentioned about it earlier also. There is something called a concordance correlation coefficient, CCC factor, not the usual correlation coefficient, which is called as a concordance correlation coefficient. And I think this one is going to appear in a paper due to appear in Statistics and Computer Applications, but the revised version has already been sent. And as I told you that when you have so many nutrition supplements, you want to see whether some of these could be interchanged, right? If I don't have eggs today, can I have fruits in the place of eggs? Or probably pulses can be brought in that place of eggs. Or is it feasible? Probably bring in some meat supplement or some calories or whatever it is. So the interchangeability of nutrients is one important aspect. So the CCC aspect, the concordance correlation coefficient, will help us to study the interchangeability as far as the nutrition supplements is concerned. And that aspect has been considered in one of the papers which already, which is due to appear soon. Now, all these are sort of a precursor to my modeling aspect. So the rest of the story, I'm sure many of you are familiar with it. I'm not going to go into the first details of the first two models or first two aspects, because I know all of even the students are very familiar with these, having listened to it from very many faculty members, probably some of the teachers, some of the scholars, and some of the lectures. But I have to give a glimpse of that particular aspect also before I go over to my joint modeling aspect. So as all of you know that a linear mixed model is one of the very basic models. And this also forms a part of all our postgraduate or graduate studies. So here also we have to look at the general form of the mixed model. You can see my model is going to be x beta plus cu plus epsilon. You have a column vector of y. You have a n into p matrix of predictor variables. You have beta of a column vector, which is going to be a fixed effects. You have a second part of random effects with a complement random variables there. And of course, the last part, epsilon, is going to be the error component. And as usual, you can have all bunch of assumptions which goes with it. And so I'm not going to go into the details of all those assumptions which goes with it. But I just want to mention that this is sort of a basic point as far as a linear mixed model is concerned. Now, the other part, I'm sure all of us know about it, especially students who are postgrad who also have done these at some point or the other, that when you have something like a data which is binary in nature, the usual linear mixed model may not be an apt one. I'm sorry about it. So you have to go in for what is known as a generalized linear mixed model. So you can see that you can think about a generalized linear mixed model. And I'm sure generalized linear mixed model is one of the fast growing areas now where you can see vast number of applications using the GLMM. So you can see that you have your yi, the jth measurement of the ith subject, and you have your generalized linear model. Probably you can see a bunch of authors who have worked on it. You have yij, which are the conditional random effects condition on the random effects pi, which belong to the exponential family here. So I have given the functional form of your phi, and which follows an exponential form, which you have your ci, and you usually have some sort of a link function. You have an eta of phi, and you can see finally it boils down to a form of xij dash beta plus zij dash beta, in which xij and zij are the k-dimensional and q-dimensional vectors of known covariate values. Beta are a k-dimensional vector of unknown fixed regression coefficients, and xi is going to be a scale parameter. So now you could see that the usual linear mixed model, which we are familiar with, probably we use it in a continuous data most often. When you have your data, which is a sort of a binary or ordinal data, we usually jump into a generalized linear mixed model, which is very vastly useful in clinical studies, in psychological studies, and so on and so forth. So I put across both those models here, basic models. I have not gone into the details of these models because I'm sure many of you already know about these particular models, and my idea is not to thrust you with these particular models, but to give you an idea about, I'm just going to make use of these two models, which I'm sure all of you are familiar with. Now, as I told you, as my title itself shows, that, okay, I have a linear mixed model now. I have a model which is going to be a generalized linear mixed model. I told you my example of a psychological data studying the human intelligence. There is one G factor, there are a bunch of S factors. Now, if I want to study the human intelligence, I have a G factor to be looked into. I have also a specific S factor, which needs to be looked into it. So both of them should go together. So I should have not a G alone, wherein I can use a linear model, or I can use a generalized linear model. Well, that is not what I'm interested in. I would like to look into a model where a G factor goes hand in hand with one of the S factors. It could be a sort of a verbal, it could be non-verbal, it could be kinesthetic, it could be musical, whatever it is. So I would like to have a joint model wherein I would like to have a sort of a model, a combination or a sort of a fusion of a linear mixed model and a generalized linear mixed model. Now you could see that probably I could say that this is one of the latest papers which I have come across, that this is a paper which appeared in 2016 by Ivanova, which talks about a joint modeling, wherein you have a continuous outcome and an ordinal outcome. So you could see a joint model which was studied for a diabetes data, wherein you have a continuous outcome and an ordinal outcome put together, and this was done for a diabetes study. Now you have two of them which are going to be ordinal in nature, and there you have what is known as both of them as a GLMM, and that has been probably a fluvoxamine trial. Probably, I think this is something similar to whatever the medicines which we are familiar with. So this is one of the clinical trials that has been carried out where you have both of them being a GLMM model. So now you have a GLMM where one is a continuous outcome, the other one is an ordinal outcome, or you can think of a joint modeling where both of them could be an ordinal outcomes. And my interest is to capture, why do I have a joint modeling? To capture the association which can improve the model fit using different combinations of random effects for the so-called over-dispersed data. So I have an association between a G factor and an S factor. I would like to have a joint model, and this joint model which I'm going to have is going to help me to study the association between the G factor and S factor, which could be a joint modeling of two outcomes which are linear and ordinal, or it could be two ordinals, and that's the reason why you have this one. Of course, when you look at the next line, probably something which all of you are familiar with. So how are you going to work on these? It's very simple. You have to look at what is known as a joint density of both the variables, y1ij and y2ij. These are the two vectors which you are going to have. So one is going to be a continuous one, and the other one is going to be an ordinal one. So you can have a model which can be expressed as you can see. One is going to be a linear model, the other one is going to be a logit model, and I have put both of the models here. And you can see that one is going to be continuous in nature, the other one, the other measurement, which is going to be an ordinal in nature. So I have taken a linear mixed model, I've taken a generalized linear model, generalized linear mixed model, and you could see that both these outcomes are going to be taken together. And you can see from these that I have different time points which are being taken into consideration. B1i and B2i are the vector random effects for the first and second outcome. So now I'm just going to have the next point, which I will try to look into is what is going to be the nature and behavior of the B1I and B2I, which are given earlier, which are two important aspects as far as the joint modeling is concerned. So you can think about the random effects B1I and B2I, which are considered to be correlated random intercepts, or it could be random intercepts and scale parameter. So the variance components are considered to describe the random effects which you are going to have. The results reveal that the joint mixed model with correlated random effects yielded a better fit for both the studies. So I have shown you that Ivanova considered two. One is a diabetes study and the other one is a clinical trial of fluvoxamine. And in both the studies, he has considered that the correlated random effects of a joint model seems to be a more apt model. One is a linear mixed model and the other one is going to be a generalized linear mixed model. Now, you can think about how to work on a joint part of it. You can think about approaching these using a classical maximum likelihood approach, which can be adapted using the joint density for the estimation of the parameters and fitting a suitable joint model for the same. So you can think about the usual classical approach for the joint density, and work has been done in this particular domain. I am not going to go into the details of it, but I just want to focus on the next aspect which I am interested in. Now, I will just go into the selection of the aspect or the selection of the model into much more detailed aspect. So in this study, what we are doing is we have considered two GLMM, that is two generalized linear models, and joint model is built for the longitudinal count data, right? These outcomes are going to be counted as far as the Kenyan study is concerned by describing a joint density of Y1ij and Y2ij of the counts Y1ij and Y2ij. So I have two functions which are going to be given as log functions, log P of Y1ij and log P2 of ij. And I have described both of them in the next few lines. Probably I will not go into the details of it, as you could see from the slide. So you could see the two outcomes and you could see all the variables that are being brought in, all the regression coefficients that are being there are all embedded in that particular model. But look at the other part or the last part of it, which is of interest to me. That is, if I have two of them at GLMM, now the interest is I want to look at B1I and B2I, which are considered to be random intercept and slope, uncorrelated random intercept and slope, correlated random intercept and slope. So you can look at all these possibilities and see which one is going to be an apt one as far as your study is concerned. So probably one could explore the possibilities of looking at all of them, or probably one could look at some of them. And what is going to be the best depends upon the data, depends upon how you're going to work on. And that is what essentially you're going to look at it. So now you could look at four different aspects as well, B1I and B2I concerned. And I have listed out all the four aspects as far as this joint model is concerned for the selection process is concerned. Now, as I told you, my interest is always data driven. So here, if you look at it, the data is basically from a Kenya school children. I am sure this is available. This is secondary data. It is not something which is a primary data, secondary data, and I'm sure all of you can look at it. It involves about 546 individuals, fairly a large amount of data. And this involves the cognitive records among the intake of nutritional supplements. And each nutrition group was comprised of 9 out of 12 schools. And these are children who are aged between 16 and 14 years. And the intervention, probably you can see the time period starting with 0. And you can see 3 different types of supplements were considered. One is meat, milk, and oil added as calories to determine the effect of Q intelligence outcome measures. So your responses are collected on the, as I said, the G matrix or the G score. And that is one factor, and probably the specific factor is also considered. So you have the time points which are available. You have the different types of interventions which are there. And we have 2 different scores which are available to us. And probably you can see the bunch of data that is available to us, about 546 individuals as far as the data is concerned. So you could see that the data was considered at round 1, which is going to be the baseline data, which is going to be a pre-intervention data. Round 2 was taken as a intervention started. You have the next 3 rounds, 3, 4, and 5 were collected at the 2nd, 4th, and the 6th month after the intervention started. So you could see at the different time points, the results were recorded. Results both in terms of G-score or what do you call the G and S scores. The 370 individuals had a full sequence data, and of course, the rest of them are missing, which is one important aspect which needs to be looked into it. And probably you can see or dissect the data, and we have seen that about 188 of them, and you can see equal amount of boys and girls are there. So gender-wise, it is very balanced. And you can see the nutrient supplements are given to about meat supplement to 126, and some of them are given milk, and some of them are given 71 of them are not given any food supplements also. And so you could see what is going to happen as far as the data description is concerned. And you can see the 4 scores which are there. One is the arithmetic score, the other one is the verbal meaning, and of course the digital span. The digital span is something where he recites and you try to recite whatever the person says. So it's a sort of a retelling the whole thing as whatever the speaker talks about. That is what your digital span is all about. So it's something like the repetition of whatever the speaker talks about. So you have an arithmetic score, you have a verbal meaning, you have a digital span. All of these are going to be a yes part of it. You have a Raven's colored progressive matrix, which is going to be one part of it. All right. Now you can see the mean plots. You have a Poisson. See, we have considered 2 different models. One is a Poisson model for the analysis, and the results are as follows. We have shown the results. The second one, just hold on for a minute, I'll be back. Sorry about it. Sorry. So you have a Poisson model. So we consider 2 different models. One is a Poisson model, and the second one is a negative binomial model. So you could see for each of the G scores and for each of the S scores, how the behavior is going to be. So you could see the negative binomial for the G score, and you have a negative binomial for arithmetic score. I think since it's going to be available, you can have a look at it. So you have your joint model now. So we consider the joint model, and we have looked at, probably you can see the joint model of the responses to study the association between G and S factor of human intelligence, and the results are tabulated. You can see the results which are available to you now. So one can look at that particular part of it. You can look at what is this? Sorry about it. Sorry. So you can see the joint model, the responses. So in order to study Raven score versus arithmetic, Raven versus verbal meaning, Raven versus the digital span total, all of them have been considered as far as this study is concerned. So we have also seen that comparing this, it is evident that there exists a better association between the Raman score and the digital span than others. So what is my idea now? I have a G score, I have an S now, I have 3 different S's which are available to me. What is the best possible thing that I could evolve? I could see that a suitable joint model is going to be with Raman score and the digital span. That is what exactly that has been evolved as far as this particular study is concerned. Dali ko tirtha madam. So now you could see whatever the model that has been talked about. So you have the model, is it robust? That needs to be answered because there's a possibility that you'll have some influential observations in that particular model. So we start with identifying the potential influential observations in the model based on the residuals in the data set. Secondly, the proposed adjustment has been made to those influential observations and fitted the joint model to compare the performance between the classical maximum likelihood and what is known as the robust maximum likelihood. So we have the influential observations which are identified. As I said, you have to make an adjustment. Probably this adjustment is basically the downsizing the observations by fitting a robust joint model between the G and S factors in this study, and the results are what we have given here. So you could see that there are a bunch of observations which we have identified. So you could see that there are a bunch of observations which are available here, and we have identified these observations. Based on these observations, we could go in for what is known as the robust model. So we have tried to look at the box plots of it. Now, I'm just going to the robust maximum likelihood model, which we try to look into it. Probably the technical part I'm skipping because I think we have very hardly about 10 minutes available with me. So what we have is we have a robust GLMM linear mixed models which are available to us, right? By an adjustment in the dependent variable, and you have you can see the mathematical aspect of how it works. So robust estimation in general actually is you can go through an iterative process, and the iterative process will help you to get the estimates for the joint model as far as the robust technique is concerned. You can see that two longitudinal count outcomes. You have I is equivalent to 1 to n and j is equivalent to 1. And what we have is, as I said, we looked at the Ivanovas type. And as I mentioned, both the log models are here. You have y1ij and y2ij. These are the two count outcomes. The time points are there. So we have gone in for a robust joint modeling, which has been worked out here. And I'm sure you can go into the details of these, which are available, I think, probably for you. Now, we have two different things which are available. The first one, which I've shown you, was a robust joint modeling, which was given based on modification of the usual maximum likelihood method. There was another method which was suggested by one group of people, McCulloch and so authors, and that is called as a Monte Carlo Newton-Raphson method. So you could see the Monte Carlo Newton-Raphson is a viable alternative, which is the alternative to the EM algorithm for finding out a maximum likelihood estimates based on incomplete data. So we try to use this Monte Carlo Newton-Raphson's method, and probably the maximum likelihood based on this particular Monte Carlo method help us to what is known as a second possibility of what is known as a robust Monte Carlo Newton-Raphson's method. So now we have a classical approach of joint modeling, we have a modified approach of using a maximum likelihood. We have a next one, which is called as a robust Monte Carlo Newton-Raphson's method. So we have 3 different approaches for joint modeling. As far as the details are concerned, I think I will leave out the nitty-gritties to you. So you can see how it is going to be like. You have your count response. You have your y1ij, which is going to be Poisson, y2ij, which is also going to be an independent Poisson. So we have 2 Poissons. So using these 2 Poissons, earlier was a negative binomial. Now we have considered 2 Poisson models, and using these Poisson models, we have used the so-called RCM Manar, and you can see the iterative process which I have listed, step 1, step 2, and so on and so forth. And I think you can see the step 3, and this is what my final outcome is all going to be. So now you can see that I have developed a joint model based on a robust Monte Carlo Newton-Raphson's method, and you can see how RCPM with each of those factors works. So you can see AS, you can see VM, you can see DS, and you can see that this particular one shows that meat supplements is going to be a very good supplement which helps in the human intelligence of school children. Now, as you know, all the models that have been developed needs to be validated. So we try to look at the bootstrapping of the data, because that's one of the very popular technique which people are using. The one very popular technique is, of course, the non-parametric bootstrap. So the non-parametric bootstrap makes no assumptions about the distributions. But as far as the population distribution is concerned. But as I told you, that what happened is when we tried to work on these and send it to a paper, one of the referees said that the bootstrapping using non-parametric technique may not be a right one. And he suggested that you should go for a parametric approach. And that's the reason why we have adopted a parametric approach, because the non-parametric bootstrap has not worked well as far as our joint modeling is concerned. So we have worked on a parametric bootstrap, which is based on the Saliban-Barrera paper. So we have noted that the proportion of outliers may be higher than those in the original data, which may lead to a non-parametric. So we therefore adopted a parametric joint modeling based on the GLM approach. So there will be a sort of an idea about what is going to be the underlying distribution, which we usually have some basic idea. So we try to make use of that particular feature. And what we have is, for the parametric bootstrap, we select the distribution type. We believe the data to come from that. And then we find the maximum likelihood parameters for that distribution. This means we find the parameter values for the distribution that gives the highest probability of observing the data values we have. Then we try to simulate the data just as we have done for the non-parametric bootstrap. We now replace each observation with a sample taken at random from the fitted population distribution. And then we try to get the bootstrap model of the estimate. So that is what we have done as far as the parametric bootstrap is concerned. Because the non-parametric bootstrap didn't work well as far as the joint modeling is concerned, so we were forced to work on a sort of a parametric bootstrap. And you could see that a sort of a glimpse of how the data is there, and probably I am sure it is going to be available to all of you, and you can make use of that particular slides to see the nitty-gritties of how the results are going to be. And we have looked at the AIC, the BIC, the log likelihood, and all these are the usual criteria one goes through before he decides about how apt this particular joint model is all going to be. Now coming to the last part of the story. So the conclusions are very important. So let me complete my presentation by presenting you the conclusions part of it. Longitudinal studies are very common and psychometric studies, particularly in studying the cognitive behavior of school children, especially that's what we have done. And there's sort of a plenty of literature which is available as far as G and S factors of intelligence is concerned. So based on the log likelihood values, we try to look at G is quite likely to be felt more, and probably in the next part, as far as the S is concerned, which is going to the digit span. That's what I told you. So the digit span of the S factor is what is going to be the most likely one which joins with the G, right? And that is going to be one of the cognitive functions which we try to look at it on the linguistic numerical, other than the two other ones which we have looked at it, because those two, especially the numeric and the linguistic, these are considered to be of the higher order domains, whereas the digital span is considered to be the lower order one, and that seems to go well or associate more well with the G factor is concerned. From the results, it is noted that the Poisson model is a suitable model in studying the association between the variables for the study. And as I said, milk has shown as a better performance or better performer. And we have tried to look at how the joint model is disturbed by the influential observations. We try to take care of the joint, the influential observations by making use of robust models, two robust models, one modified based on the maximum likelihood, and the other based on the Monte Carlo method, which is based on the EM algorithm. So we have two robust methods, we have one classical method, we have three different methods for joint modeling. And so we have taken all of them, three different ones of them, and based on these adjustments, we have tried to look at the performance of the school children as far as the nutritional supplements are concerned. So, and we have shown that probably taking 2 GLMM, fitting a joint model, and a joint model with robust Monte Carlo seems to be a more apt method rather than going for a single linear mixed model or a single generalized linear model of either G factor or S factor, because both G factor and S factor together are important in studying the human intelligence. So with these few words, I want to say thank you for giving me this opportunity to present some of the findings as far as this particular joint modeling is concerned, and hope this particular results will enthuse some of them to take up some of the work, some of the data which is available locally, and build some joint models based on that. Thank you once again for the organizers giving me an opportunity to present my findings. And probably, I think some of the references are given. And of course, it's very important that I should acknowledge Gokul, because he's the backbone. So all I do is probably giving ideas to work on. So he has to do sort of the core work. So he has been doing the core work as far as this particular model, joint modeling is concerned. So I've acknowledged Gokul also. So thank you very much once again for giving me this opportunity. Yes, I think I'm up to the time. Yeah.
Madam, can you consolidate the questions from the chat box, madam, please?
Sir, actually, there is no questions from the chat box.
Okay. Then the participants, if you want to have any interaction with the resource person, please raise your hand. We will ask you to unmute. Then you can clarify your doubts with the resource person, please.
Yeah. Somebody is there?
Yes, sir. Yes, sir. We are here. Hello.
Shall I, sir?
Yeah.
Yeah, please.
I thank the professor for his wonderful presentation on joint modeling. I think it's an open problem, and it's an application side, and most of us could take up such a joint modeling and do research on that one. I have a doubt on the validity of the model, sir. It's not on your model. Generally, I'm asking you about this. I've seen papers on this application side the validity of the model, they used to do AIC, BIC, and then log likelihood.
Right.
All will have the it has the same result, or it will reveal only the same. Why do we want to do all AIC, BIC, and log likelihood?
Yeah. Oh, that's a sort of the usual question which people ask. Why should I do all of them? Why should I do AIC? Why should I do BIC? Well, this is a question which people quite often ask. Indeed, I raise this question again and again to many people. The question is, well, if you're confident about AIC, live with the AIC. Nobody is asking you to do BIC. So the reason that people are doing all these AIC, BIC, and so on and so forth, because as you see, even in the selection of models, but when you do forward, when you do backward, when you do all the stepwise, none of them in some cases will tally. Because if you see the select of variables, forward may give a bunch of variables, the backward may give a bunch of variables, and probably the stepwise may give a bunch of variables as a part of the modeling exercise. So similarly, when you go about as far as the likelihood criteria or any of these criteria like AIC or BIC, people often try to see whether all of them tend to tally together so that your confidence level goes up, saying that AIC, BIC, likelihood, all of them tend to be same, and so I am on a safer wicket. If you feel that if you feel that there's a sort of a discrepancy saying that AIC is going to give you a better value, whereas BIC is not so, then obviously there should be a proper justification saying that why you are going to justify saying that I should look at only AIC and why not BIC, or if you look at BIC, why not I look at AIC. So the questions are quite wide open as far as the options are concerned. But people always, not only these two, I think there is also adjusted AIC and so on and so forth, which are available to you. So one can look at all other options, but invariably, some people say, don't go for all these, you stick on to one and try to argue that I will stick on to AIC and look at it only. It's a question of very open question. One can look at any options, and if all of them get tally, I think it happened here, I'm more comfortable. If they tend to differ, probably I have to give more reasoning to it than that. That's all.
Rahim sir.
Yes, madam. One Madam Kalaivani has raised
Kalaivani and Edwin Raja. Kalaivani
okay.
and.
First, we'll ask to Kalaivani. Madam, you unmute yourself and you can ask, madam.
Yeah.
Kalaivani, madam, you can please unmute yourself and you can speak now.
Told that Monte Carlo simulation for Newton by using Newton-Raphson method. Can I apply for reliability theory, sir?
Can you apply for?
Hello.
Okay.
Yeah.
Reliability theory, sir.
Okay.
I'm sorry.
You apply. You told.
I got your question. Can you apply for reliability theory? Am I right? That's what your question is?
Yeah, sir. Monte
Carlo methods can be applied.
Or Newton-Raphson method, including Newton-Raphson.
That's going to be a part of the procedure. That's a part of the procedure. It's an iterative procedure there. But Monte Carlo methods can be applied there also. So reliability, see, as far as this one is concerned, this one seems to be a best alternative. We try to look into it for especially the EM algorithm, expected maximization. So as far as the reliability is concerned, how to use of it, how to make use of it, I think that needs
for
to
estimation, for estimation, parameter estimation, I want to use it, sir. Can I do what?
Monte Carlo, you can use it.
Use it. Is there any special Newton-Raphson along with Newton-Raphson? It is better, no? Compare with that.
Sorry, I don't know. I'm not clear about what is. See, the process Newton-Raphson is basically an iterative procedure.
An iterative, yeah, sir.
Yeah, so
separate or it's a combination of two, sir.
That is going to be a part of that. What I have shown is the Monte Carlo technique in the process of estimation makes use of a procedure, an iterative procedure, like the Newton-Raphson iterative procedure in order to get the estimate. That's what.
Okay, sir. Thank you, sir.
Sir, Dr. Sampath Sundaram, sir, please.
Sampath is there, sir.
Yeah.
Hello.
Yeah.
Can you hear me?
Yes, yes.
Yeah, just I will take a few seconds. Just I would like to supplement what Dr. MRS told. What I feel, no, we have several validating measures, even in machine learning also. This is with reference to the choice of AIC, BAC, and so on. I think all these measures are influenced by the nature of the data set. That is what I feel. So we have to be very careful in choosing that. We cannot blindly tell you go for AIC or BAC. See, if such a simple answer can be given, then there is no need for different validating measures. So each validating measure will be affected by the nature of the data set. So that is what I wanted to add with what Dr. Emmer has told. Am I making it clear, sir?
Yeah. Thank you. I think probably you clarified more than what I did.
No, it's not like that. Just I wanted to add, because see, we used to have a F measure as the best one. Now they have found that it is easily getting affected by for some particular data sets. So for such data sets, we have to go for a different kind of adjustment. That is why they have gone for adjusted BAC, adjusted AIC, and so on. That is what I wanted to add with Dr. Emmer has told. Am I correct, sir?
Thank you.
Okay. That's all.
Yeah.
Rahim sir, Professor Edwin Raja also raised his hand.
Previously, but not now. 1 minute, madam. Anyhow, if he wants, let him also talk. Edwin Raja, sir, please. Yeah. Now, Dr. Edwin Raja, Mr. Edwin Raja, sir, you can.
Hello.
Please.
Sir, it's such a
Yeah,
great
you are audible.
pleasure
You please go ahead.
Such a pleasure to listen to Professor MR's lecture again. And
Sorry?
has given a very detailed discussion on the many complex method of estimation procedure.
Sorry, can you speak a bit louder, please?
It is such a great pleasure to listen to Professor MR's lecture again and a very detailed discussion on the many complex method of estimation procedure. Primarily, there are two major statistical methods available to analyze the longitudinal data. One is the mixed method, which you have described. Another is the population average method through the generalized linear equation procedure. In GEE, working correlation structure is assumed to estimate or adjust for standard error of the estimation due to the correlation. I just wanted to know from you, can we apply the joint model methods using the GE methodology, GE estimation procedure?
Sorry, what are the two models that you're talking about?
Yeah, for the basically to analyze the longitudinal data, we use two statistical methods. One is the mixed method, which you have described. A linear mixed model or generalized linear mixed model. Another one is called as a population average model that is estimated using generalized estimating equation, and we supply working correlation structure to adjust for standard error.
So your interest is you want to have one of them or both of them as a generalized estimating equations. Am I right?
No. I just wanted to know from you whether we can use this joint methodology in the GE methodology also. Can we apply the joint modeling in the GE methodology?
Maybe. I have no idea. I've not looked into that detail as far as using the GE methodology is concerned. I have no idea about that particular part of it. I'm sorry about it.
No problem. Thank you very much, sir.
Thank you so much.
Rahim sir, is there anybody on the queue?
No, sir. No hand raising.
Shall I take few minutes?
Yeah, sir.
Shall
You
I?
can. Yeah, please.
Yeah, that's why. If there are somebody, I can withdraw. That's why. Sir, it's a well presented lecture. I have one question or doubt, so to call. See, you are starting with a model which involves both fixed factors and random factors. That is with X and Z initially to begin with. My question is, if and also at later stages we are going to use non-linear stepwise Monte Carlo techniques to estimate the process, estimate the parameters.
Right.
So whether your fixed factor vector dimensions and random factor vector dimensions, do they matter? Do you have any restrictions over that P and Q? If you call P to be the dimension of fixed factors and Q to be the dimension of random factor,
no.
It's totally independent.
No. See, the model can be anything. So it has nothing to do what is P and what is Q. So that's the reason why I gave you, see, it's a general model, X beta plus ZU. So it can be anything. So you can have a bunch of random factors, you can have a bunch of fixed factors. Am I right? That's what your question is all about?
Yeah, exactly. Because that number at some stages may, because since you are using it for solving, I thought you could come across some problems of convergence, which may, if there is a balance or if there is a restriction like P should be greater than Q or 2 times. So something of that sort. If everything is random, we are going to be estimating more variance components, thereby the parameters gets reduced.
It all depends upon what your objective is all about. If your interest is in studying the variance component, then obviously your random components is going to increase. If your interest is going to be a fixed part, then see here the variances are important for us. So we have taken the variance part as a predominant one. But it is up to you to take whatever number of factors you want. But as you said, as your seminar is all about a higher dimension, the more you have, the complexity will increase. That's all.
Okay, sir. One more question about the ordinal variables that you are using in the model.
Right.
Are you directly feeding the ordinal variables into the model, or do you convert it into, say, something like a dummy binary and you are using it? The ordinal.
In the generalized linear mixed model?
Yeah. Because you have y1i and y2i.
Yeah.
And your y2i are ordinal, it seems.
Yeah, that is being taken care of in the generalized linear mixed model using a link function. So you don't have to worry about it. That is taken care of using the link function. Suitable link function, I have given the link function also. The link function takes care of it.
So that means you can use directly
the
ordinal variable. No need to convert into dummy coded.
The conversion, you have to be careful about it.
Okay.
Yeah.
Okay, thank you, Professor. Thanks for the explanation. Is there anybody on the queue, Professor? Professor Rahim?
Sir, no, nobody is there, sir.
I think then we can thank the professor and okay, Renuka madam, you can proceed with the thanking process.
Thank you, sir. Thank you, sir, for your enlightening talk on joint modeling in data analysis. Department of Statistics, Presidency College, OU, special thanks for accepting our invitation. On behalf of Principal IQAC team, head staff members of Department of Statistics, Presidency College, I take the privilege of thanking you, sir, for having come here and giving this lecture, special lecture. Thank you, sir. Thank you very much.
Thank you one and all, and thank you, Professor Sampath. Thank you very much.
Jayashree madam, you can call for the next.
Thank you, sir, for your. Hello.
Hello. Proceed, madam. You are audible.
Okay, sir. Now we'll move on to the second session by Professor PonnuRaja, sir, from ICMR. And there is, as I told you, we had a small change, and I request all the participants to bear with us. Our Martin sir's presentation will be only in the afternoon session. So I call upon Professor Sundaram sir to introduce the resource person. Professor Sundaram sir is there?
Yes, am I audible?
Audible,
yes,
Professor. Please carry on.
Okay.
Good morning to all participating in this webinar. It is a great pleasure for me to introduce our resource person, Dr. C. PonnuRaja sir, scientist E and head Department of Statistics, National Institute for Research in Tuberculosis, Indian Council of Medical Research, Chennai 31. He is a very nice person. Okay. When I was working as a research assistant, epidemiology unit, NIRT, ICMR, JECPET, Sir was the scientist C rank in the Department of Statistics, NIRT, ICMR. Whenever I ask academic help, immediately he will say, okay, no problem. I definitely do that. Such kind of words I really appreciate, sir. Sir, still helping PG student for internship program and the research scholars, faculties to do the research work. In the point of research, educational qualification, Sir did BSc at St. Joseph College, Trichy. Then MSc Statistics did in University of Madras, and PhD Statistics did at University of Madras. Then research experience, 20 years research experience in the clinical trial, 23 years data processing, analyzing and programming experience. Sir guiding 5 students, 3 students awarded and 2 students progress. In the point of publication, Sir published more than 75 publications in scientific journals and published one book on the title based in priority model. The author Chennai and PonnuRaja and thermal integration. The publisher Lambert Academic Publishing what is that, 2000, in the year 2010. Okay. Sir received one Young Scientist Award by Indian Society for Medical Statistics during 2010. And the research area, Sir was concentrating survival analysis, data mining, big data, and meta-analysis. Now, Sir is a membership in scientific bodies. The member Indian Society for Medical Statistics, member International Biometric Society Indian region. Today, Sir topic is infectious disease modeling and forecasting the COVID-19 outbreak in TN SIRD approach. Now our participants are eagerly waiting for your wonderful research speech, sir. Now, hence I request our research person, Dr. C. PonnuRaja, sir, to take this session. Thank you, sir.
Yeah, very good morning. Is it audible, sir? Hello?
Sir, it's audible. You can proceed.
Yeah, thank you, sir. Thank you very much. Thank you, Dr. Sundaram.
Sir, excuse me, sir. Please on your video also, sir, so that we are able to see you, sir. Please. So, PonnuRaja, sir.
Yeah, fine. No problem. No problem. Yeah, sure, sir. Is it fine, sir?
Please go ahead, sir. Now it's okay, sir.
Yeah. Thank you very much. Good morning to all. Yeah, thank you very much. Yeah, this topic, I think this is a COVID-19. This is kind of an infectious disease. So hope you all understand the problem for modeling with infectious disease versus non-infectious diseases. So non-infectious diseases we did, but we don't have any problem of accounting factors. Whereas infectious diseases is really challenging, and forecasting with this same thing, it is really amazing one. Now we applied here is SIRD. This is kind of a compartment model. Purely this is a mathematical model. But one interesting thing is I hope you all are aware of mathematical model versus statistical model. So the mathematical model doesn't have any error component and it never depends on the hypothetical values, but statistical model includes error model. Also, it depends some kind of a hypothetical nature. But this compartment model though we have call it this as a mathematical model, but it forecasts everything will be based on hypothetical nature. That is the beauty of this model. Base model is SIR, that means a susceptible infectious recover. But what I need is the D is mainly we need to assess the actual risk of the disease. Whether we have a severe epidemic or not will be based on death only. So that is my interest. I added SIR along with the D for this presentation. So the complete presentation consists of the abstract of the presentation. So hope it has in the process of publications. We published two more paper in the same area. We've calculated different R naught for Indian level as well as the high risk area of India. The R naught is one of the important factor, which is really interesting factor. Of course, you all are familiar with the R naught, but the R naught plays a vital role for especially this kind of a compartment model. And something we want to know about COVID-19. Why? Because those who are working with healthcare as well as the hospital based, they know the prevention from the virus. But I would like to say something about what is the risk and how we can prevent, how it spreads. This information is really essential for non-healthcare industry people. So those who are having or dealing with student, how it could be prevented from strategy. We don't have any medicine for preventing the disease, but we have to prevent ourselves. That is the only interesting thing of the COVID-19. We unable to see the virus, but we need to prevent. Nobody knows where it starts, where how it spreads, but it is kind of infectious. The only difference between the bacteria as well as virus is this is virus family, whereas tuberculosis is also an infectious disease, but that is a bacteria family. So I just want to elaborate something about COVID-19. And in the interesting things is like the basic reproduction number, the R naught. People used to tell R naught or reproduction number, both are similar, but it is not infection rate. It is a reproduction number. This number plays a vital role, and also how it plays to identify the severity of the disease, either in the epidemic or in the pandemic. R naught plays a vital role, but the R naught will be calculated using different kind of a method. But I am going to say something, the major methods for calculating R naught. So the R naught will be calculated different situations during the outbreak as well as the epidemic or pandemic or complete. Once it is completed, we can calculate the R naught, and in the beginning we can. So these combinations, what are the methods available? Accordingly, I am presenting here, but I am following only one method, which is maximum likelihood estimate method. Though the time dependent method is opt for this, but ML is ideal for this kind of uh, calculation for calculating or not, because we are calculating different phases of data. That means this is kind of a data driven different phases, in the sense we are still in the fifth, I think sixth phase of the lockdown, whether it has kind of an impact or not. But we want to assess the severity of the disease from the beginning to till date. So that is the thing. The ML method plays a vital role for R naught, but we have different methods. Whichever it's possible, we can do. So other approach for calculating R naught is approach is ideal for this kind of a scenario. And the subsequently, I would like to say about the compartment models. What is the approach we are going for calculating or projecting using the things like ordinary differential equation plays a vital role for compartment model. And SIR is a deterministic model. And of course, we added one more component. D is another component. All four components are independent. It is only a basic model. We started recently after the pandemic started. After the January, we started the course, like doing kind of a infectious disease modeling, especially for COVID. We started doing using this model. Of course, this is familiar for all others, but this is really new for me. We started during 2019 very beginning. And the it can add any compartment, many compartment. It is, we can go even 100 or 200 also. If you have a capacity of doing differential equation, that will be that won't be any problem. Instead of depending on any kind of a software for doing ODE, better manual way to assess the ODE procedures to forecasting this kind of approach. And the last one, the modeling and forecasting using the TN data, Tamil Nadu data, using R software. How R software helps to project this kind of forecasting method. And finally, there are kind of issues in while you are depending on this kind of a compartmental, especially SIRD. Some issues are there. We can't say this is a perfect one. We can say nothing is perfect. That is the assumption we have since we are a statistician. Nothing is perfect. We cannot say this is 100% correct classification also. So that way, the SIRD also has kind of a limitations. Experts are there how it could be sorted out so that we can improve further with the same SIRD for forecasting of this kind of a disease. So this is the background. So this is of course a mathematical model. I added apart from SAR D component. The D stands for dead, S stands for susceptible, and I stands for infectious, R stands for recovered, and D stands for death. This is my model. And the reproduction number plays a vital role, I told. Here the total population of Tamil Nadu, I took only Tamil Nadu. So I don't, the reason for selecting Tamil Nadu is we can depend the data with the open source is very much easy than compared to all other states. But during our data preparation, Tamil Nadu data much better than compared to all other states. Some of the states, though we can call it this is a capital, but the way they are projecting the data is not that much perfect. In fact, it is not up to the level of our requirement. So Tamil Nadu data is somehow better, and moreover, they are updating in the everyday evening. So by 11 o'clock or 12 o'clock, the particular day data will be uploaded in the, it is available for the open source. And the simulation shows the trend of infection that occurred different scenario. Simulated data is compared with the actual data. Also, we are comparing the reported data with the everyday projection. Also, we did different phases, whether we have any benefit during the lockdown. Lockdown is one of the important thing. That means social distancing, making social distancing in a broad way, whether it has kind of an impact or not. And also we are assessing the outbreak, the severity of the outbreak during different phases. Something about the coronavirus. It is a family of virus that causes illness ranging from the common cold to more severe disease, such as, it is called two different scenario. One is Middle East respiratory syndrome, that is MERS-CoV, and the second one is severe acute respiratory syndrome. These are all classifying the severity of the disease. So my MERS is something mild than compared to SARS, SARS. The SARS is not a new one to the society. It is a familiar one, the terminology. Also, the COVID also is a familiar one. But the sources of COVID is, it is kind of a zoonotic, meaning they are transmitted from animal to human. There is no evidence it is transmitting human to human. Once the infected person can infect other human, that is the way, but the origin is from animal. So the probable animals like cat also one of the reason for spreading COVID, and bat as well as camel. These are the evidence-based information gathered how COVID transmitted from animal. Majorly, we identified these are the animals are spreading this kind of a virus to human. Obviously, we used to call this is a novel coronavirus because there is no evidence that the corona is transmitted from human to human. So the pathogen of this virus is new for human society. And yeah, as like this is a family of virus affecting respiratory tract. So as like a tuberculosis, it's the same kind of a way. It is affecting thoracic related. It's affecting lung because it is kind of a respiratory tracking system and causing disease from a common cold to pneumonia. So the pneumonia is one of the major problem they used to have in the kind of a lung or other respiratory tract, like usually lives bat and other wild animals. It is one of the important source we have evidence. So statistician always depend on kind of evidence. If I'm saying this is spread, this virus spread from a cat or camel or bat, but I have evidence. So it is a WHO given kind of evidence that it is a reported one. We don't have any evidence that other animals spreading the disease, but in fact tiger also infected in US, but there is no evidence that tiger spread to the human, because wild animals, the movement between animals to human is very less than compared to the domestic animals. While if you are having kind of a camel as well as a cat also, it's kind of a domestic animals. There is a chances, there are much chances to spread easily. In fact, tiger has, but I don't think tiger spread the disease to human. So wild animals, of course, having, but there is no evidence that it spreads human directly. So maybe the interaction between human as well as wild animals is limited than compared to domestic animals. That is one of the reason. Transmitted to human directly or via other animals, can also transmit between human via respiratory droplets. Once the infected person can transmit it to other person through kind of a droplets or kind of a coughing, sneezing, whatever the way. This is kind of a structure of coronavirus. Of course, everything is in the same biological way of uh, complete structure as it is in the natural way. But from this, we don't have any evidence that this is one of the kind of people or talking or social media spreading things like this is artificially created. We don't have any evidence that, but it has kind of a biological structure. So with that, we can believe that this is a kind of a natural thing. We don't have any evidence that this is artificial one, but according to the structure, it is purely biological way. And why do we call this is a novel coronavirus? Because there is no evidence that the new strain is a coronavirus that has not been previously identified in a human. That is the only way we can call this as a new novel coronavirus or coronavirus of new thing to the human, novel coronavirus. And the novel coronavirus now called 2019. We have different names to call this kind of a virus. Like 2019 started. That is a way we can call 2019. N stands for novel, and CO stands for corona, and V stands for virus, D stands for disease. 19 is the year started. That means the December it started. To that we can call it this as a COVID-19. And other names like coronavirus, COVID 2019, and COVID respiratory, novel coronavirus, pneumonia, because pneumonia is a common name. And Wuhan, once it is affected at Wuhan, they reported to the WHO, this is kind of a pneumonia. They have evidence that this is kind of a COVID. So the word COVID coined by WHO later stage after identifying the diseases. And it has kind of a path, like a journey, interesting journey, like it started. That means China alerts WHO to several pneumonia cases. They haven't say like this is corona, but they reported as a pneumonia cases. December 31st, they reported to WHO. Previously, they have kind of a cases, but officially they reported 31st December, reported to WHO. They alert like this. These are the cases common in Wuhan. The report was submitted on 31st December. Subsequently, January 2nd, France confirms Europe's first coronavirus cases. But though we can call this is a coronavirus, I don't think they have reported as like a coronavirus cases, because the corona identified later stage. We have kind of a suspicious whether this is related to corona or not. The same Wuhan doctor also coined this as kind of a coronavirus, but there is no evidence that we have a proper idea this is related to virus family. But January 11th, China announces first death from coronavirus. So they identified, but there is no confirmatory sources. This is because of corona death. And later we came to know that because of that virus, the death happened. Then we call it this is a corona death on January 11th. January 13, WHO reports cases in Thailand, the first outside of China cases. And subsequently, January 30, China alerts WHO to several pneumonia cases again. And February 2nd, the first death outside China reported in Philippines. And February 7, Chinese doctor who identified the coronavirus dies because of COVID. And February 11th only, WHO names this called coronavirus. This is related to virus called COVID-19. And up to that stage, we don't have any proper evidence according to WHO guideline as well as WHO recommendations. So February 11 only we identified at India. We used to call this as a corona, but so that kind of a unconfirmed sources. Though after February 11 only we got this is a clearly saying it is related to biological factors. Also, it is a virus family, and this is called COVID, corona related things. In fact, 2006, maybe I don't know, 5-10 years back, the COVID affected cows. We have history, but we don't have any evidence that it is spreading to human. Those days, we got some kind of idea about even SARS. Also, we have still SARS happened in the Europe, African country quite long term back, but we don't have any evidence or confirmative medicine for even SARS also. So still we are getting medicine for or any kind of a vaccine for corona. But recently we have some source. It is in the Covaxin. Covaxin is the only source of vaccine identified with the help of some between one Icemer Institute as well as another biotech in Hyderabad. So they identified this kind of a vaccine, and this is kind of the first phase. Now there are 3 phases we need to marketing the medicine. It is in the second phase now. So first phase is completed, the second phase is running. Probably it is comes like a third phase very soon. I hope today is the day to start with the third phase. Probably they will start different places, about 10 places in India. They're investigating the safety and efficacy of the vaccine. Another 14 to 15 days, we will get some kind of a report, and we can collect some kind of evidence that whether this is actually effective of the particular vaccine or not, and particular virus or not. And subsequently we want to assess the side effect also, that is a toxic mode. So the toxic will be very less. It is assessed, and we need to confirm with the larger population. That is the phase 3 of controlled clinical trial. It started yesterday. I think the 7th of this month like to start. But we will get some kind of evidence where they have started. The first case was admitted for this Covaxin trial. And this is the journey about COVID-19. And we have some kind of evidence that the government of India confirmed that India's first case related to this COVID diseases on 30 January 2020 in the state Kerala. The student came from Wuhan, traveled back to the state. That is the first case we identified. We are familiar with the COVID-19 cases. As the number of confirmed COVID-19 positive cases, it's close to 500. And we observed according to the government of India, we announced kind of a Janata curfew. So on Sunday of 22nd March, then subsequently we are in lockdown. So the first lockdown started on 24th March, announced that the nationwide lockdown for about 21 days. But still we are in different phases of same lockdown. We can say whatever it is, but after the 22nd March, we are in lockdown only. And we identified different phases. I told previously what is the reason for calculating or not using ML. So before going to that, I would like to say the symptoms so that we will get some kind of awareness, like so shortness of breath is one of the major cause of symptoms, and high fever. And sometimes people used to have kind of a symptoms of vomiting. It is a very less percentage than compared to fever as well as the breathlessness. And diarrhea also is one of the reason for the symptom of coronavirus. Coughing and pneumonia are common for as usual respiratory. So the high fever is about 88% sources of confirming symptoms. The problem is, though we have categorized the percentage of symptoms happen or identifying COVID-19 cases, so the major contribution to the fever and the second contribution to the dry cough about 68%. Subsequently, other symptoms like mucus production 33%, fatigue 30%, sore throat 15%, muscle pain 15%, and shortness of breath is 90%. These are all common symptoms in terms of percentage. We would like to always announce like how many percentage of having symptoms fever. That is the way it's classified. And another petty thing is nowadays people are identifying with the positive cases without having symptoms. So that is very risk then compared to the symptoms cases. If I know symptoms, I can diagnose. Maybe this will be useful for doctors to diagnose easily. Having diseases, but there is no symptoms at all, it is very risky. And WHO want like message giving like old age people will get quickly, and they are the people or high risk people for this kind of a virus because of they have any kind of other comorbidity conditions like diabetic, as well as some other kind of heart diseases, something like um, there are medical problems like high blood pressure and heart problems or kind of diabetics. These are the uh, other issues will also lead to the severity of the diseases. But according to the Indian scenario, there is no kind of a things like it is common for irrespective of all age group. It is not only for the older people also, but only thing is other issues like blood pressure and diabetics are the high risk people, we can say. Even for younger age people have this kind of issue, probably they will be in trouble. So because having COVID cases, if the person is having kind of a shortness of breath, so for treating shortness of breath, people used to give kind of steroid content medicine. But the patient is imagine the patient is having diabetes or hypertension. So treating for shortness of breath, it, without having or patient is having other diseases like a diabetes, it suits up. So the treating for that kind of a patient is really critical. So they may lead to severity stage, but simultaneously we have to give a treatment for both diabetic or any kind of a hypertension, say, along with COVID. So if I'm treating for COVID, if a patient is having other comorbidity conditions, they may suit up with their own diseases, and it lead to some kind of a seriousness by the WHO. It is uniformly same irrespective of worldwide people. And this is the mode of transformations like sneeze or cough by infected person is one of the source to infect through droplets. That this is the infect droplets, and through that infected droplets get on your hand by touching other hands or touching surface of any kind of a things like any kind of a, even in fact if you are using table sneezing, someone is touching the table, can get easily the virus through there, and virus transfer to other people. So this is after infected person to how the disease transmission is doing. So the disease transmission, the duration of disease transmission is calculated uniformly for 5 to 14 days. In that aspect, the entire model is projected. Though we have a duration of infection is a hidden factor here for calculating reproduction number or not, but the duration of infection is the one of the important thing to assess the reproduction. What do you mean by reproduction number? This is expected number of secondary infections arising from a single infected individual during the infectious period in a fully susceptible population. So the problem is how to select my susceptible population. Since you are in India, someone is infected in Tamil Nadu, will you account the whole Indian population as a susceptible, or you can take the Tamil Nadu population is the susceptible? That is a debate between researchers. So according to this scenario, I took susceptible population, the Tamil Nadu population, so about 7.7 crores of population, assuming probably it may high. And according to the census record as well as other reporting sources, we come to conclude that the 7.7 is the picture. So through some sources, everything based on kind of evidence, but defining susceptible population is two way. One is it is related to epidemic or pandemic. Pandemic kind of a portion. Epidemic is a universe. So if it is a epidemic, I need to take the entire population is a susceptible population. They are prone to get infected. So the R naught formula is the transmission probability per exposure into the number of contact per unit time into the duration of infectiousness. So the duration of infectiousness based on the medical evidence, this virus will spread minimum of, it can take, the positivity will be identified if a person is infected. Symptoms will be identified or asymptomatic during the period between 5 to 14 days maximum. If someone is exceed 14 days, the cases is very length. The huge amount of cases getting positive between this period. This is identified based on different sources, and based on the evidence only, research only, we are having the same conclusion, and accordingly we calculated the R naught here. So different scenario of R naught. If R naught is greater than 1, this is called epidemic. That means the severity of the diseases. And R naught equal to 1, this is not kind of a severity. Also, we cannot say this is no risk for the society. Something is there, but still it is manageable. When R naught is less than 1, obviously when time progresses, the virus dies out. This is the common scenario. But the question is, the virus is, we have the or not according, irrespective of any country, any scenario, it is not going below 1. So that means we are in moving upward. So the progression of the disease is still, it is going. There is no decline at all. The decline will be coming, you see, from this projection, you will wonder like how the peak is going and decline starts where. It takes about nearly 6 months. It purely depends on the basic reproduction number, which is nothing but attack rate into contact. Here the or death is, as well as the time is not directly get into the picture. That means the duration of infection or infection period is essential for or not, but it is kind of a hidden factor. But we are accounting indirectly. How? See, for example, if I'm saying the attack rate is 40%, imagine that this is one infected person is infected. The red one is infected. He is going to infect in the population about 40%. Out of 5, he is infecting 2%, about 40% attack rate. My R naught equal to 2. If the second scenario, the same individual is infecting, it is another scenario. He is infecting 60% of my population. So the R naught equal to 3. If I am calculating right now, you assume that my R naught is like a 3 in the sense 60% of the people will get infected. So another worst scenario is, imagine that R naught equal to 5. That means the attack rate is 100%. So one person infect another whole population within a short span of time. So, but as such, you cannot assume that what is the duration behind this calculation. That is a question now. So how this is related to, you just recollect my previous word, like the duration of infection is a common one. You can refer any reference, whatever you have. So the same scenario, I'm doing the same exercise manually, then I am confirming with my projection. So imagine that the duration of infection is 5 to 14 days. I am taking the minimum one. So if the duration is really 5 days, I'm not taking 6 days, 7 days, up to 14 days. If you are calculating 14 days, maybe it can vary. So this is mainly for first 5 days. Every 5 days I'm calculating. If a person is infected, can infect one person on the baseline. Subsequently, he infect another 5 days, 2 cases will be added. So you look at 30 days, 64 cases will be infected. At the time of 60 days, every five days period. At the time of 60 days, 4,096 cases can infect over a period of 2 months when R not equal to 2. That means a person infect 2%. That means the attack rate of 40%. The second scenario, the R not equal to 3. So the corresponding 30 days when R not equal to same R not equal to 2, same duration. At the time of 30 days, it's about 64 cases. At the when R not equal to 3, the corresponding 30 days, it's about 729 cases. It's not a matter of fact. When you look at 60 days, when R not equal to 2, it is about 4,096 cases, whereas here 5,31 cases, 31,441 cases at the time of 60 when R not equal to 3. Imagine when R not equal to 5. When R not equal to 5, at the time of 30 days, corresponding R not equal to 2 is 64, R not 3 equal to 729, and R not 5 equal to 15,625 cases will get infected. And at the time of 60 days, imagine 24 crores and 41 lakhs 40,625 cases. So R not equal to 5 is the worst scenario. Attack rate is 100%. If it is attack rate is 100%, you will get this kind of things. So this is a population. You see, imagine that it is not even Tamil Nadu population, 24 crores. So according to the census, India population is roughly about 130 crores. So imagine that at the time of 60 days, so nearly 20%, of course, 25% of the people will get infected. It is a worst scenario. So whenever R not equal to more than 1, that is a worst scenario. That means the severity of the diseases. This is the manual calculation during 5. So the infection may get in terms of 6 days, 7 days, like you can calculate in terms of the duration of up to 14 days you can calculate. If you calculate 14 days, probably the number will get reduced, definitely. This is one way of explaining things like how the importance of R naught. So the disease decline when R naught equal to 0, there is no infected cases and there is no chances of getting other to infect. And this scenario, when R not equal to 1, one person is infected, he is going to infect another person, like it is going to, it's a kind of a stability, disease stability. And disease spread, we can identify when R not equal to 2, he in the infected light blue person is infected cases, he can able to infect another 2 person, another person can infect another 2, this person. The chain will go like during a short time point. This is kind of a basic reproduction number illustrations, and exponential growth rate is always there for in yearly epidemic. And uh, we can assess when R not equal to 10, so that means a shorter period we can have a peak. If R not equal to reduces, like the duration of peak, this peak will obviously moves down. So this is the strategy behind that for R naught. So if you have high R naught, you will get immediate peak like this. See, this is the immediate peak when R naught equal to 5. These are all worst scenario. I am giving just example. As such, we don't have any more than 2. But initially we have R naught equal to even 3.1 also. But we have been questioned by the ministry. Then we explain. So the thing is, the initial stage, we don't have any recovery. So R not always influencing recovery, not death. So R not directly influencing infectious as well as recovery, but it is not, death is not influencing or not. But the death we need to calculate because we want to assess the epidemic as well as the severity of the disease in the society. There is a one aspect, we added one more component D, that is my internet. But I said different method for calculating or not. So according to the scenario, exponential growth is one type of method to calculate or not, will be most appropriate in the initial phase of the disease outbreak. It is mainly for initial phase of the disease outbreak, but we splitted the reported data according to different phases. I splitted first 21 days and subsequently next lockdown. Likewise, we splitted the data and we used, but it is not applicable for exponential growth, that kind of a scenario. Maybe that is kind of a data driven concept. I have some kind of a data, so accordingly I calculated. So the second one is maximum likelihood estimation. It relies on assumption that the number of secondary cases caused by a index case is related to Poisson distributed with expected value. And the third one is sequential based, as usual, the Bayesian way of calculation. But during outbreak as well as progressing outbreak, I don't think the sequential Bayesian will be applicable. We don't have any evidence that. But these are all important things, and time dependent is another interesting one. When time progresses, how the outbreak is showing importance. So that way we can calculate the time dependent as well as maximum likelihood estimation. But I prefer here is maximum likelihood. If anyone suggested with any of the method which is opt for calculating or not during this scenario, it's really helping for the society. And this is kind of a cumulative death as on 20 June 2020, according to different important cities in Delhi, in India. So how the Mumbai is technically leading for having more death cases than compared to Chennai cases. This is a little interesting one. Because of this reason, we started another study. So there are evidence that previously we have been in your right or left hand, you can have kind of a scar like BCG scar. If you have that kind of a scar, automatically, so the death rate of this scenario, those who are having a BCG vaccine implemented initially, so that also preventing the COVID diseases. So it is not getting infected, but you will be prevented from death. So definitely you will be infected. Maybe there are chances, but recovery is quite easy than compared to the complicated one. So why? Because it is evidence that WHO also suggested the same thing. We reported the death rate, those who have BCG vaccinated, is about 3.6% all over India. Maybe it is varying according to the state, but the same trend is reflecting Tamil Nadu. So Tamil Nadu is reflecting the original scenario of 3.6% death, those who are infected with COVID. It is reflected in Chennai as well as Tamil Nadu data. In fact, we are blessed with kind of a very not even 1%, but there are states reporting with high death rate. So Chennai, Mumbai, and Calcutta, Delhi. If you look at that one, Delhi as well as Mumbai leading this different trend, whereas Chennai and Calcutta is almost close to the smallest. Even not even that time, it is not even more than 1,000 cases. But we progressing with the death. But when compared to other thing, still we are in the less than 1% criteria. So because of that BCG, if you are revaccinating the elder people, also prevent the death. We started cases study like the same kind of a revaccinating BCG because of that findings. And I'm coming for the compartment model now. So we need to have a large amount of explanation for or not. The compartment model is I don't think it is No need to explain all those because these are all components are familiar for us, our people. The compartment model is a type of mathematical model, that is to say a model that can describe by a set of mathematical equation that simulate how individuals in different compartment in a population interact. So my simple doubt is, I have a susceptible population of, imagine that Tamil Nadu total cases is 7.7 crore. So this is my susceptible population. At any time, anybody will get infected with the infect. So the here a person getting infected, and there are two reasons. One, the person get recovered, or the person experience the event. If you assume that a person is recovered, so the recovered person also will go back to the susceptible population. This is the scenario. But here we are very stringent to include that the susceptible population. So though the recovered people will go back again the susceptible, because there are reason to have a reinfection, but we don't have any reinfections scenario as such, but it is there in originality. You assume that the recovered person will again go back to the susceptible population, but according to the compartment model, I should not include. So all compartment will be independent. That means susceptible to infection, then infection will have another compartment from infection to either it has to go back to recovered or go back to death. This is the two option. It should not go, the recovered cases cannot include in the susceptible again. So but ultimately it is going back, but we are assuming these are all kind of assumptions. So we need to follow the same one, but the ODE is the important one. It plays a vital role. We can calculate using regression concept also, but ODE is an interesting one. It helps to do kind of this kind of a compartment model using progressing with, but there are kind of four procedures to follow. So if you follow the ODE, but this is the scenario we have to follow. Imagine the population size is n, but if I calculate the rate of change of this population over time, this is dn by dt is the rate of change. If any changes, that means if dn dt is a large or positive, the population growing quickly. Or you imagine that the dn dt is small and negative, the population is declining slowly. So the growing is quickly in the sense birth rate is high, declining in the sense death rate. So you just imagine that way. Any kind of a thing, if something is giving additional, that is kind of a birth, or something is the susceptible will lose people that because of died, so the susceptible will gain people because of birth. So these are the two assumptions we need to have. So the example one, if we assume that the population is constant, dn dt equal to 0, there is no issues. That means n is 0, meaning that dn dt. And if population is growing at a constant rate, with a constant rate, then dn dt equal to c, some positive number. It is a growing way. It is just a simple example of a differential equation. And the third thing is growing at a rate of population to n. Something is contributing in some source, like n is proportional to n, meaning that dn by dt equal to some b into n. Some positive number is b. B is a positive number. The fourth scenario, birth and death rates. Birth and death rate number of population is proportional to n and new numbers. Some, if you assume that this is the death rate, exit from population. So adding to the population is birth rate, exit from the population is death rate. Because of these two reasons, we can, so the S will improve or S will change according to these two scenarios. What is the ODE expression here? So the birth rate, new number of population is population to n is kind of a thing like, so if it is birth, I should add, that means this is kind of a positive sign. The B consists of positive sign. So the death will obviously in the negative. So this is the two scenario. One is positive, another is negative. Accordingly, we have to plan the entire compartment. It's like yes, what is the nature of yes? What is the nature of I? What is the nature of R? What is the nature of D? Likewise, we have to plan for our scenario. So when B, birth rate is greater than D, the equation is like dn by dt equal to some constant B into n minus D into n. So the B is adding something, D is existing something. That means it is going out from the population. That is a scenario. So here the novel coronavirus, the R naught, as I said, R naught. Why I'm coming back to R naught? Because there is a standard threshold limit for any kind of a disease. So for novel coronavirus, the R naught definitely will not go below that one, or it should not go, or it is not going above the threshold 1.3 to 3.5. This is the suggested or not by the world references, WHO reference. So according to that, we conforming with this thing. Suppose I am ended with some 9.5, my R naught is calculated based on some kind of a data. If comes like 5 point something or 9 point something, something like go below that, there won't be any problem. So this is really a, so anything related to more than one is a risky one. So according to that scenario, the estimated coronavirus, or it can range between these number. So if I'm saying, so my population is well, really bad situations, my R naught either in 1.3 above or 3 point less than 3.5. If I'm reporting 11 point something or 10 point something, it is not kind of a things like, maybe the calculation which I did is really a wrong one. Likewise, they framed R naught for irrespective of all diseases, cardiac diseases, kind of all kind of infectious, non-infectious, related to everything, any kind of a healthcare issues will be calculated, assessed according to the reproduction number. So this number mainly for corona reference 1.3 to 3.5 is a WHO reference. For that reasons, so this is the guy presented, this one was accepted by the WHO standard. And now I am coming back to my SIR deterministic model. As I said, S stands for susceptible, and I stands for infectious, and R stands for removal or recovered. So you look at my states: susceptible, then susceptible to infection, the infection to recovered. That's all. I don't have any compartment for death. So that is the reasons I having in mind to add one more compartment, death, for that reason. So I set one scenario: a person get infected, subsequently recovered. So after recovered from the disease, where he will automatically go back to susceptible. If I put my compartment like this, it's, if I'm connecting that one, it is a wrong one. I should not. So that means susceptible population is a part of population. Infection also is a part of population. Recovered also part of which, all are independent. That is one assumption we have to follow. My compartment model. So yes, susceptible, infection, infected can go back as a recovered, or if infection severity of the diseases will lead to die. These are the parameter to estimate. These are kind of a rates. So this is a simple differential equation for SIRD. If this is the scenario, we have to. So I said 4 different criteria. If my population, my susceptible will portion of people will get infected, that will be subtracted. That is the reason I put minus sign. If anything to be added, so I need to put positive sign. So that is a concept. According to the same concept, the differential equation was framed, and this is the common one. If you look at any reference, you will get the same thing. The population is a n, which consists of S, I, R. The initial conditions, like always start with the baseline 0, or it's kind of a 1. So infected people, total number of cases is, for example, 1000. One is infected, then none is 0. Then what is my projection for so over a period of some times we can do it. So this is for the additional, the new proposed technique, which is susceptible, infection, and recovered. The D included as a death, because I know SIR, there is no problem, but with the SIR, we cannot decide that the severity of the disease in the society. So if I'm adding D, so according to the, see, imagine, so if death is more, you people always talk about, see, because of COVID, we have a lot of death. But current scenario, you look at in Tamil Nadu, we have more than 50% of recovered cases. We are not talking about always, but we are ultimately, though we have a less than 1%, but still we are talking about death. But that is a one concept. Death should be included. Death is one of the important factor to assess the severity of the disease, which will be noted as very severe. See, death is there in other infectious diseases like tuberculosis, but no one is afraid of that kind of a death. Even in fact, if you look at 6% died in a minute. So we have that kind of a scenario, but no one is looking that death is severe, because the COVID death is we are taking more serious than compared to all other. Though we have a death, more death in infectious disease, same infectious disease like a tuberculosis, we never talk about all those things, but we are worried about it. One, it is infected. Ultimately, we mindset will be either we will go off or we will be died because of COVID. That kind of a social stigma. I never believe that it was happened as usual. It was created. So this kind of a panic will be created by someone else. Because nobody knows about the severity of the disease. That is the reason probably we will more exaggerate the disease severity. So strictly speaking, according to this scenario, what we projected is about nearly 70% will get infected. But how many will die? That is the thing that we need to assess. So in this scenario, this is the uh, differential equation for this compartment. If I'm adding one more component, my calculation will really a complicated one. So imagine that this is 3 or 4 compartment. If you add n number of compartment, imagine 100, 200 people are trying. So there are work in the abroad is still progressing for infectious disease. We can have more compartments. Someone is see, if we are started implementing vaccine, so that will be added one more component. So receiving vaccine, who is recovered because of receiving vaccine is high, or not receiving vaccine is high. As such, we don't have evidence, but we have recovered cases. What is the background behind that? So we are getting our own sustainability. So whoever is recovered because of their own immunity. So if the virus is there in the body, will get automatically go off another 7 days. This is also one of the evidence-based report, but no one is believe that one. We are always in the position to get the vaccine. So like vaccine will get things or night other compartment, like see, I said previously before starting my 85% of the cases have asymptomatic cases. Only 5% or 15% cases can have a symptoms along with positive cases, but 85% of the people having positive COVID, but there is no symptoms at all. So those cases will be have another compartment. If anyone interested, you can add in compartment, like compartment adding. So this is 4 compartment. You can add compartment like, so adding compartment more and more, the equations will be really a tough one. So that is the reason if you are depending on some kind of software like MATLAB or whatever it is for differential equation calculation. So my suggestion is, as a statistician, we need to validate manually. Then for validation purpose, we can depend on any kind of a software. That is ideal way. If I'm feeling, so if I'm wrong, you can just correct me. And sorry. And so the beta and gamma, the mortality rate will be calculated according to the definition. So the beta is nothing but we are here mentioning here. This is one of the way we can calculate the transmission rate. The gamma is average recovery rate, and the mortality rate is mu divided by mu or delta. So I used to call this as a mu. Some scenario you can find delta also. You said death rate or disease also will be called as delta. And this is case fatality rate divided by duration of infection period. You will get mortality rate. So obviously the duration of infection period plays a vital role for any compartment model. And the whole exercise will be depend on two software. One is R, another is Python. So for calculating R, the for calculating all parameters like beta, gamma, mortality rate, I depend on Python. And after getting all the parameter for projection purpose, R is supporting using two libraries. One is ggplot to plot the data, projected data, and dsolve is mainly for solving the ODE, the problem for differential equations or any kind of things related to the dsolve. We know, of course, you all are familiar with R. In fact, your nowadays students are having more knowledge about R. There is no problem. So if you look at three compartment, the susceptible will be the black one, black line. So this is a population, total population. Once it is infected, some portion of population will go to the red and some portion will go to the blue. That means removed or recovered. That is our concept. Adding one compartment like death. So according to the death, this is a projected one. So the presentation will tell you the overview about the way we can proceed further. But how we can do with the R, that is, I will do R using the same parameter using the live R. So I'm stopping here my presentation. I will come back with any, if you have any queries. Now I am sharing my slides. Now I am sharing R. So can you able to see the screen now? Anyone from admin side?
Yes, sir. Yes, sir. Seeing.
Yeah, is it visible, sir?
Yes, sir. Yes, sir.
Yeah, yeah. Thank you very much. So I told the two libraries in the R. I'm running using R Studio. So one is dsolve. So dsolve is executed, and library is a graphic for the ggplot. And my initial value here, the problem. So you look at the highlighted number. This is the population. I would like to say one more additional informations related to my activities. I recently I got permission to work for Tamil Nadu Dr. MGR Medical University. We started during March itself. So with the different sources, I got this number for doing this one. If you have any kind of a current scenario, someone have a so recent population is Tamil Nadu population is around 8 crores or 9 crores. There is no problem. So if you are changing this one, so we will get some kind of influences in the infectious cases. It is not influencing any kind of a recovered as well as death cases if you are changing the population. But strictly speaking, the changes also, it is very, very meager. It is not that much changes giving kind of an infection. So that means it is wrong, something. If I'm changing the susceptible population, the infection rate, infection number is changing means it is wrong. It should not. So calculating the beta susceptible will plays a vital role. So if I'm adding that one, there is a mild changes in calculating the beta, that is the infection rate. So the gamma is in our model, this is a recovery rate and this is the death rate. So in a particular day, so that it is not kind of a thing, it is not law. This is the day of 1st June. Reported cases is infected cases is 23,495. I think 1st or 19. I will check. Yeah, I have a graph saying here. Yes, 1st June, 1st June to 19th June. So this is the one phase. Actually, different phases. I said it is. I think this is a 5th phase of lockdown. And accordingly, whether we have any, it has any impact or not, we want to assess. So this is the initial value, that is the first day reported cases of state government. 23495. This is recovered cases 13,170. This is death cases reported on particular day. And this is my input infection rate, and this is a susceptible population. That means a susceptible population is nothing but cases. Some portion will be go into the infected cases, and some portion will be the recovered cases and death cases. Subtracted from all these cases, we will get the actual susceptible cases. This is a total n, and this is the recovered cases, and this is the death cases on particular diet. The parameter which I'm going to give is the beta infection rate is according to this. That means the transmission rate, and gamma is a kind of average recovery rate, and mu is the CFR divided by total duration of infection period. That is a mortality rate. The mu is, and I initialize my value. Also, I'm initializing my parameter. See, for some reason, I'm giving my times. That means a sequence I need to generate for about 300 days. So we can do for even 10 days or 30 days, whatever it is, there won't be any issue at all. So when we are looking far ahead, something can happen. See, for example, another couple of weeks, we will get vaccine. Because of the vaccine, we will get something, the infection rate will get reduced. So it may change. So we need to consider. Only looking the graph, I am giving the sequence is 0 to 300. So, for example, put 100 days. From the initial to 100 days, I am generating kind of a things. It is mainly for 100 days. What is the drawback if I'm only thing is I cannot visualize the graph properly. That is the only issue. And I'm running the model. So the output will be as usual. So the output will be given for 100 days. The 100th day, so this will be the total population, and this will be the infected cases, and this will be the recovered cases, and this will be the death cases. From June 1st to plus 100 days, imagine that you will have, this is the projection number. This I'm telling the hypothetical value only. Now I would like to plot accordingly. See, if you look at the plot, this is not that much, it is not giving clarity. So we can find the decline in the susceptible. So you look at this one, you can find the decline. I think this is something like it is improving, like something is susceptible will be declining. We know the reason. Susceptible population will split it into infected, recovered, and death. So, but my graph is not that much hard to look at the things, like though we have legend and all, we unable to identify what happened, when will be the peak we want to know. So the maximum peak will be, see, imagine that this is the maximum peak. It's about 13,44,206 cases. But I want to change, I need to generate some more number for looking the graph efficiently. Say I'm doing the same exercise for 300 days from June 1st to 300 days. I'm running here, and I can view only 200 days. I don't record even 300 days only because of visualizing my graph. I'm doing the exercise again. Now we can look, something is a peak and something like up. Like if you add legends again, that this will be, see, imagine here, if I'm running here, so the peak will be 15 lakhs 63 no 1 crore 56 lakhs and 35,538. This is the real scenario. But we can assume that for projection is about 300 days from 1st June to 19th June. The data is given. This is the kind of a data driven concept. 1st to 19, I put the data, and I'm taking the baseline is 1st to June. But according to the issues, there are issues I said. what are the issues like? The first thing is if I'm feeding as the initial value on the first day of June, that means whatever the reported cases on 1st June, I included as the initial value. So instead, I can include as a cumulative, so I will get some more accurate results. So these are the way we can fine tune our model. There are many flaws probably, but how it could be a proper way to express the actual projection. So really this is an interesting one. At the initial stage we can shape the model in a better way with your expertise, and I'm ready to join hands with you people, academician, obviously. They are very sound in solving equations as well as doing kind of a theoretical way. So though we have applications without having theoretical, it is really a drawback one. So that way, if anyone ready to correct the things like this model in a better way to project further for the society, really a happy one. So you look at here, the 200 day, roughly about the infection will go. So that means the first day is the initial value. This is the initial value. It goes, the red is infected cases. The maximum infected cases will comes like here, like 1 crore 55 something, like another 200 days. 200, roughly 210 or 211, this is the case. And look at the death one, it is also, it is slightly improving, and how much it is we will see now. I'm just copying. So I would like to share one more file for sorry. Yeah. Is it visible to everyone?
Yes, sir. Yes.
Yeah, fine. Thank you very much. Yeah. So the highlighted area is given data. So that means reported data. So 23495. So 2349 fed as a base value. You look at the second one, 24478 and 25502. These are all projected scores. So I took for calculating or not as well as the parameter based on the reported value on the highlighted phases, highlighted values. So this is the highlighted area, this area. That means this range, first 20 rows, sorry, 19 rows, except the heading. So this is the reported, already reported on, based on the reported cases. Given the first day as a base, I'm verifying whether this is close to the projected or reported or not. So in fact, from second onwards, these are all projected one. It is not reported one. So I am going to compare with the existing one. Almost it is close to each other, except death. Almost it is very close to the scenario. So while we are doing the first phase as well as the previous phase, I will save the graph and reshape. Yeah. Look at here about the peak will be in somewhere in 200 something, like, see, the peak is 1 crore 56. 1 crore 56 lakhs and 35,000. It is somewhere in 200, about 200. So there is a peak. If you look at peak, will be 21st December. You will get the peak according to this scenario. So this is kind of a projection only. So people will get panic like, so this much cases will infected. No, it will not happen, because some, what is the reason I'm telling you? So people are getting so much awareness about COVID. They are nowadays, everybody is wearing mask. So even social distancing also maintaining, even kids also maintaining the same thing. So that is one way of preventing the disease. Probably that could be the reason for we will get reduced in infection rates. Probably we will have the peak will be in a shorter period, a little bit earlier also. So that means so when we started with March, we got peak at May. Now this is not the scenario. Still we are progressing. Peak is going as like a that is also progressing in a future way. So that will not be happen because of we have sources like some news that we will have kind of a vaccine very shortly. Also people get some kind of awareness, self rescue, self prevention. People are getting more awareness. See, those days if someone is coughing, we don't have any bothered about person is coughing. But nowadays no one is coughing because of kind of if I'm coughing like in common place, maybe it will people will treat me like anything. So that is also is there. So that is really a bad attitude to develop kind of a this kind of a stigma, treating for the positive cases. It is not good way. Like this is the peak will be in somewhere 21st of December. Subsequently we will the cases will be reduced. Even if time progresses, see, look at the same scenario will go. We will have a peak, but next year May, so what will be the cases? So this is one of the I keep opening point to have care about this virus. Also we are getting ready or making the facilities, medical facilities, to make available for the public. So calculate based on this one, I can able to calculate how many beds is actually required, what is the measures I have to take to prevent. So these kind of a things only because of the R naught. So the R naught plays a vital role. So which gives the exact scenario of the outbreak. So this is kind of a cautioning message. This is not kind of things like making people to get panic more. So we need not worried about all those things if you are following kind of a self-care, self-prevention like. So with this, I would like to thank everyone for this presentation, and I'm stopped sharing. Thank you all for participating in this presentation. Thank you, sir.
Thank you, Professor. Thank you, Professor.
Thank you.
Rahim, sir, can you see any persons raising the questions?
I am, sir. One Dr. Dr. R.V. Prasad has raised the hand. I will ask them.
Yeah, sure.
So, Dr. R.V. Prasad, sir, you can now unmute yourself and you can ask. Yes, sir. Dr. R.V. Prasad, sir, please, you can now talk, sir.
Sir, please unmute.
He has unmuted, but a little
okay.
louder, sir. Please, louder, please, sir. So, sir, you unmute yourself, sir. Please, you have again muted yourself. You unmute yourself and speak, sir. Please.
Not able to hear, sir.
Sir, one question. One participant asking one question, sir. Hello.
Yeah, at least you can convey the questions what they have asked.
Yeah.
Yeah, please.
Just I tell you, itching also a cause for COVID for a pneumonia patient. Itching.
Yes, sir. Yes, sir.
Itching also a cause for COVID for a pneumonia.
See,
what is
they're
the
related
to what is the solution to solve itching in the whole body?
So that means he is asking about the symptoms about COVID.
Yes,
you know,
yes, yes.
Is it related to symptom of the COVID? or something like he wants to add kind of a compartment model for another things.
Symptom.
So this is kind of one of the symptoms.
Symptom.
Okay, fine.
You are not mentioned in the slide.
Yeah. See. The thing is, whatever the major sources, major causes, really this is plays something like higher. I presented more than 15% having kind of a common symptoms will be presented here. Probably we have itching also. So I haven't see there are quite a lot we have symptoms related to that one, but the common is fever. It is about nearly 88%. So that is presented with only 50%. So rest of the 85% we don't have any evidence like symptoms. So 85% cases there are reported saying nearly 80 to 80% having asymptomatic but COVID positive. But there is no evidence of whether he has any kind of issues like probably itching also one of the reasons. It is comes less than 10%. I omitted purposely because if you add all even 0.01 0.02 also is kind of a percentage. So that is the reason I make my slides clarity. The major common symptoms for COVID is presented.
I think Professor Radha is raising physically her hands.
Yes.
So that she can, Madam, you can ask to proceed with your question. Madam, you can proceed with your question. Professor Radha. Question answer session. Okay. No problem, sir.
One Dr. Swain from Utkal University also is having some doubts, sir.
Yes, sir. Please, sir. Please convey.
I think Dr. Swain from Utkal University.
Yeah.
Sir, can you hear me, sir?
Yeah,
I'm
we
Dr.
can hear.
Swain.
Yes, sir.
Sir, it was very nice presentation, and actually, I am also working in the same field. So I am just curious to know the initial parameters. I mean, for infection rate and the recovery rate, beta, gamma, mu, how you have taken these values? I mean, is there any basis for taking calculation or something you have used?
Yes, sir. The calculation which I have calculated based on the formula. So I provided in my slides also. In fact, I would like to convey the CFR. Just a mortality rate is nothing but CFR divided by duration of infection. This is the common formula. But CFR is another formula. Like we have written so many lines to calculate that thing in Python. So which is not we can convert into R, but sometimes we are running with R. I don't have others having any problem or not, but I'm having problem. It is hanging something like it is go off automatically. That is the reason we switched to Python to calculate the same thing. So the R naught calculation also using the same thing. So the main projection will be in R. So we did as well as what we learned from the initial during the class, as like you attended the class. I attended previously, like my master used to tell everything is an OR is a perfect one, but I migrated to something like a MATLAB for doing kind of a compartment model equations. I'm very familiar with the slight that means the basic one. If I'm adding, so we added even 50 compartments. So we have kind of a clinical trial. According to the clinical trial setup, we added more than 50 compartments. So it is very difficult to do kind of a differential equation. So for that reason, I migrated some portion of my program is in Python, especially for calculating infection rate as well as the growth rate, also for the mortality rate. So this comes using the same one, using the common formula. The reference I added in my presentation, I will show here right now. So it is recently published in the PLOS One paper. Both data presented in Wuhan as well as around the China places. We have common structure to have calculate the infection rate as well as other parameters.
Thank you.
Will you move to the next question?
Yeah, now Mr. Stephen Raj has.
Yes, please.
Yeah, please. Stephen Raj, sir, please.
Sir, good afternoon, sir.
Stephen, you can proceed.
Yeah, good afternoon, Stephen.
Sir, while calculating R naught, at initial stage there was some issues with that recovery rate, no, sir?
Exactly.
So for that we can add some. For that we can add some constant to the model, sir. Actually, what we do in
because
regression like that. Yes,
it is not the correct way. See, the thing is, R0 will be definitely is susceptible divided by infection, susceptible divided by infection divided by recovery. So if I'm having very low R0 at the initial stage, in fact we don't have any R0. See, R0 range is 1.3 to 3.5. You can view my presentation. See, presented previously, but that is a range given by the WHO as well as other common places. But we ended up with, at the initial stage, we have 3.1 R0. So what is the reason? We have very less recovery rate. That is the reason we got. But if I'm adding some constant or something else, we cannot compensate. So I projected with R0. The same question was asked by the ministry, the state government, and I explained the same thing, like this is the reason, and subsequently we come with a kind of a range. Now we ended up with kind of things like 1.15. 1.12 actually. In fact, we ended up with the R0 is something like during the same population we have R0 is I will show 1.106. 1.106 current scenario for 1st June to 19th June to we have about just about 1. Also, the 3 scenario, like according to R0 is more than 1 is epidemic, and that is a severe things, and R0 is stable when R0 equal to 1 and R0 equal to less than 1. So we are closing to probably 1, but it is the time of traveling towards a peak. Also, it is one of the things like how the R0 is influenced because of we have a high recovery rate.
Okay,
so that we need to project, that we need to project correctly. We cannot add any kind of a compensate constant or any kind of a dummy thing. So I have some issues. I need to clarify here itself. The SIRD model, we are facing kind of issues like from the beginning, if I'm having my component D has 0, for example, the day 1 we have kind of a infected cases is 1, recovered cases is 0, but death cases also 0. If subsequently I am generating cases like 0, that is one issue. And later cases, at the end of my data, as for example, my the date phase is 19 days for the thing 1 to 19. The 19th date, if I'm having the similar number just prior to the 18th date, that is also another problem. So there I added 1 number in addition to the previous one. So that is the reason we have something like so we adding 1 also is reflecting huge in death rate.
Exactly.
So we need to avoid. See, there are professors like experts are there. If you are ready to come with how to solve this issue, we will definitely have this kind of SIRD model for India perfectly.
Okay, thank you, sir.
Thank you.
Okay, sir. Now, Dr. Prasad, sir, can you try now? Dr. Prasad, we have asked you to unmute. Please speak, sir. Prasad, sir, please speak. I think some problem with this audio. So now we'll call Jayapalan Mr. Jayapalan Vijay Rangam.
Hello, sir. Am I audible, sir?
Yeah, it is audible, sir.
Yes.
Please.
Sir, as you mentioned earlier, there are many methods to calculate R0.
Yeah.
Actually, I tried using weekly variation from 11th April, 1st April data onwards.
Okay.
As you mentioned, my R0 initially was around 10, and it has gradually come down to 1.5.
Yes, sir.
But I feel that you are saying 1.0. Are there any means to standardize R0 calculations?
No, we don't have any standardized R0, but we also adjusted something like, see, for example, we tried all over all state as well as all district in Tamil Nadu also. Now I am working with Chengalpattu. If you look at Chengalpattu, previously we did for same work Chennai as well as Tamil Nadu, same trend. There is no problem. And when compared to district level, Chennai versus Madurai, drastic changes. What is the problem? Still I am blinking. So there is no issues in the data. But obviously, if you are saying like during the beginning, you are calculating the R naught is more than 10.
Yes, sir.
And yeah, so we also ended up with all the above procedure we tried previously, and we also have these kind of huge values. In fact, time dependent, you just started with the time dependent, it is not working with the initial initial period of calculation of R naught during the initial period of disease. It is giving kind of a things like, even in fact you are ended up with 10 at least, but I'm ended up with even 11, 12. That is, it is going up the same data it is giving by other technique like maximum likelihood, and even kind of a Bayesian also, it is working good for that scenario. And subsequently, my ML method is giving a proper than compared to time dependent. But when time progresses, time dependent also it's giving similar or not using as like in the ML procedure. That issues I cannot assess because my knowledge is very limited than compared to academician. But if anyone is familiar that concept, which is opt, and in fact we tried or not also for a different approach for different phases, and we published a paper. But whether this is the correct way of thing, like we moved, we need to assess. So we also have the same problem, but ultimately we have references as like I ended with even SARS R naught is drastically different from COVID R naught, but these are all same family. How can I say what is the issues in the data? So these are all some unknown issues are there. Still, I'm see. Recently, we did for Chengalpattu data. Chengalpattu data is giving perfectly then compared to Madurai. Then Madurai data is we are accumulating days. Subsequently, we started somewhere in beginning of June, but July also we included the same result we got even today. So there is no proper there we have kind of a optimization technique. Optimization technique adjust only infection as well as recovery. It failed to account the death. So other compartment fails automatically. Then I need to compensate irrespective of all compartment should be in the similar way. But we are lacking to apply for optimization technique also. So which can I could not generalize which is the better one for that one. So I need to try to say this is the perfect one for all. I don't feel that is there any way of making or adjusting the data. Maybe I have worried that people are accumulating data subsequently. For example, today's is such a huge data. Maybe this will be accounted subsequently whenever I am getting low data. Whatever reporting cases obviously presented reported previously 3 days ago. So the results arrived based on the past 3 days. That means after receiving the getting results, the getting results in the period of results for about 3 days to 4 days. It is not exactly the same day result. So also some kind of issues of accumulating something like I have that kind of a worry, but I don't have any evidence that they are accumulating data.
Thank you. Thank you, sir.
Yeah.
Next, Madam Anmol Jena. Madam Anmol Jena, you can unmute yourself, please.
Yes, sir. Am I audible, sir?
Yeah,
you are very much, please.
Okay, thank you, sir. Good afternoon, sir. It is a very thoughtful, provoking presentation. And my question is, what is the behavior of an SAR model and SBIR epidemic model while using in the study of epidemiological phenomena?
Yeah. So we are dealing kind of how the disease, the impact of the disease in the society. Also, it is how it spreads among people over a period. The over a period is hidden, and spreading disease to the people we want to assess. So this is kind of related to epidemiological aspect. But the word I'm coining is related to epidemic or pandemic. It's really interesting thing to identify. So if I'm saying this is a epidemic, this is completely I'm looking around the universe. irrespective of any
Yes, sir.
places. Of course, COVID is universe. There is no doubt at all. Some previously, you just imagine the previous SARS. SARS is not familiar in India, so it is familiar in somehow in African countries. Now you are calculating here that is a pandemic. So the people is calculating there in the Africa, that is a
Yes, sir.
epidemic. The people, those who are away of Africa, if I'm calculating this is, so if I'm concentrating all the world, some portion is affected, which is Africa, that is a pandemic. So I can include that portion alone. So that is a difference between these two terminology.
Is there any difference, sir? Basic reproductive number you while using
Yeah, there is
SIR
no
model and
difference in
SBIR?
the, yeah, there is no difference, madam. See, the reproduction number is calculating reproduction number either in the
Any
epidemic or in the pandemic.
distinction, sir?
Yeah,
Yes.
I checked according to
Okay.
my experience. I'm telling like there is a small changes in the infection rate. So
Okay,
obviously
sir.
it affect or not also very mild changes, because
Okay.
instead of pandemic I am including epidemic, my infection rate will reduce automatically because my denominator is high. So that is the thing. Maybe that could influence the or not. So I need to plan properly whether this is a pandemic or epidemic. Epidemic means I need to include universe. Pandemic means some portion of the
Mhm.
population. Yeah.
Oh. Sir, is there any range like R naught is between 1 or 0 to 1? Yes.
Yeah, exactly, ma'am.
Is there any range?
Yeah, I gave kind of a range of references provided by the WHO. It is in universal range, 1.3 to some like 3.5. So if I'm saying like my R naught is like 5 according to this scenario, maybe it is in the very severe stage. So every disease have their own or not. Some of the disease have even 11 also is there, madam.
Okay.
For according to this scenario, this is given the range is mainly for COVID.
Okay, sir.
Yeah, thank you, ma'am. Thank you very much.
One more participant, Dr. Sedil Vasudevan. Maybe probably this will be the last question. Dr. Sedil Vasudevan.
I'm Dr. Senthil Vasudevan
Yes,
from
sir.
Riyadh. I'm working in Riyadh. Nice presentation by you, sir. I'm
Thank you, sir.
very, it is a very informative and a very nice presentation. My question is the infected person that is informed by the government. So that is by tested only. So actually the testing is to be increased. Then we will get the number of persons affected is more also. No? So that is my point.
Yeah.
Kindly tell
Fine, sir. Fine,
that
sir.
way. Yeah.
Yeah, sure, sir. Sure, sir. See, we are looking the world like who is having more cases. The person who is having more cases now, they are facing problem because of not extending their testing facilities. Just look at US. US is huge in size, so they are having more than 25 lakhs people infected. Nearly they are closing 30. So the reason is initially they omitted, they ignored to test more people. So they thought that it will not be a problem, probably that reason. For our, it is a problem of money. So we unable to spend a lot, probably that could be one of the reasons. So nowadays, everybody, irrespective of all, they learn point like that we need to extend our testing facilities. So then we can able to, it is not the meaning of eradicate, at least we can reduce getting, spreading the diseases.
Yes.
So probably if you could extend the testing facilities, you will have more cases initially so that you can prevent them. That is one option, but it is not feasible to do. See, for nearly 130 crores, nearly 135 crores people are in India. You just imagine that you want to buy a mask for a single person, how much it costs. So that is also another issue. Maybe so this cost is varying. Maybe we need to standardize the testing facilities with the limited things like. So previously we suggested kind of a things like the test kit roughly about 300 400, and the people approaching the private hospital charging like high. So in that way, either way people are suffering to get facilities. So the government has to make it common for irrespective of all. So it was suggested a very nice question, because the like burden of disease is one of the major role directly indirectly influencing our per capita income. So it is really influencing our economic status also. If I am buying for a test kit for everybody in a single time, so that is also waste of. Maybe we can do at the initial stage randomly. Maybe we can include gradually increase 5% improvement, 10%, like gradually if you are improving like the testing facilities in terms of percentage over a crowded area, that could prevent reasonably, sir.
So awareness is very important.
Yeah, nowadays awareness alone. So we need to prevent from our own knowledge. That is the thing I'm exploring my presentation more related to COVID things.
Thank
So
you very
it
much.
is the only yeah, thank you, sir. Thank you very much, sir.
Okay, thank you, sir. Thank you for
Hello,
the
sir.
organizer also.
Hello, sir.
Really thank for them, sir.
Sindhu,
Hello, sir.
Yeah.
Hello.
Request from a Sindhu from chat box for asking question. You want to ask any
No
question,
problem.
Madam Sindhu?
Hello, sir.
Audible,
Yeah.
please.
Am I audible?
Yes, madam. Audible, madam. Yeah, yeah, please.
I am. Okay. Sir, namaskar, sir. It was a nice presentation.
Thank you,
I'm
madam.
Sindhumal.
Yes, madam. Please.
Am I audible to you, sir?
Yeah, audible, madam. Please.
Yeah, I have a couple of questions, sir.
Yeah, please, ma'am.
Like one thing is about the R note only. Like everything is depends upon how you choose R note. It seems like if you are not correctly choosing R note, that means even the smallest difference makes a very large difference in the end. So
Okay.
it's like that based on like for example, based on the data from the first lockdown period, okay, is there any we can make an estimate on R not for our scenario, and you can study for the impact of a lockdown for various stages like that. Can we study in that way? It looks like that because your gamma beta everything will be changed, okay, based on, okay, if you fix
Yes,
one
madam. I agree,
particular
madam.
lockdown period for estimating all those things, and go for that projection, okay, what is really happening over the lockdown sessions, okay. Is it possible like that, sir?
Madam, you are correct. There is no doubt at all. But the thing is, so without having medicine or without having vaccine, we are saying recovered from disease. So obviously, the initial stage, we don't have any much recovered cases. The whole world is blinking because of no vaccine, no drug for this kind of things. In fact, we treated some patients with the malaria drug hydroxychloroquine. So it has a side effect. Obviously, all phenylchloroquine tablets are causing cardiac issues. If a patient is really having cardiac issues, it lead because of the QTC prolongations. Taking medicines over a period of time is go up. So once it is the QTC prolongation is going up, it will obviously lead to cardiac issues. And recently there are studies like saying at the initial stage we unable to understand what is the scenario of the disease. So that thing having more infection, but no, there is no recovered cases. Nowadays we have huge recovered cases, but there are not recovered cases as well as infectious cases. With these two parameters only we can able to calculate the R naught, but death is nowhere related to R naught. It is not at all influencing R naught. These are the two factors, only two factors. Even if you have n number of compartments, these are the two factors are able to are using for calculating or influencing the R naught. So initial stage, really, this is we don't have any much cases on recovered, as well as the cases are prolonging. Infected cases are going even it started growing more than 100 or 200 also. Then we identified one single cases recovered that day. So in fact, you look at the past data. So initial first 1 month as well as 2 months, the recovered cases is very, very limited. So we have accounted cases not only because of the treatment, also their self-own immunity power. That is also is there. So having diseases, uh, working with our immunity system, then the virus will be killed by automatically our own immunity also. That is also one of the things, like the mutation will be um, fail to um, spread further. So even our immunity system has to understand the virus status. Accordingly, it has to work. We need to have kind of a time for developing kind of a pathogen. Some changes will be there in the, so it will take time. So for calculating or not, we need to understand there are many methods is available. These are the method which we tried initially, and we get some kind of a knowledge over there, and some of the reference also suggested when we have kind of a data in terms of phases, and the ML will be the ideal tool then compared to time dependent. But time dependent also is the ideal tool, but it is not working at the initial stage. So
Yes,
initial stage, their exponential growth is ideal one, but we tried exponential growth. Because of some reasons, we stick on to ML method only.
Yeah,
So
for
that is the reason,
India
ma'am.
in the initial stage, it was not exponential. Later on, later
Yeah,
stage,
yeah.
it was
Yeah. That is the reason we never tried for exponential growth at the initial stage. It is see, all statistician used to compare with the other one. So if for my data something is opt for that scenario, I cannot generalize for all others, but it is applicable for that scenario. That scenario will be identified as. Subsequently, if I am applying the same method for the data wherever I am getting other places, I can generalize. So that comparative evidence only I am presenting here. So with the different approaches as well as different data sets, we tried with the same technique, and we come to conclude not only our own experience, also based on the experience done at somewhere else in other than other countries also. So we are applying initially only Asian region. So China as well as other places are the reference for the Indian data, and subsequently we ended with other regions, Europe countries also we compared. In fact, nowadays we compared with America also. So now it is quite similar than compared to all others. So I don't think maybe the comparison is not wrong. Is according to statistical concept, whatever the way we need to compare, so the similar quality will be compared. For example, if I want to compare the people like eating food, so the food also is one of the important thing to have the symptoms as well as disease severity. So whatever we are having the similar trend of including food, so I need to compare. Like, so for example, if I want to compare Tamil Nadu people with other state, so maybe their food habit will change. I can go even South India. If I'm going apart from South India, I can compare with West Bengal, because West Bengal also rice eaters. So if I want to compare the same trend to other countries, like if I do the same exercise with other countries, I can go with Japan, because Japan as well as some of the Asian countries are having rice eaters, and especially other Asian countries, Japan is having more like what we are having rice, they are having the same. So one way I can correlate people are having the same similarity. Likewise, we need to compare. So that is also another reason, madam.
All right. The second question is just related to data, sir, because the data are daily based data keeps coming only. Is there any system that you can see from January onwards, or maybe at least February onwards, when India it started on February onwards? So from that day to till today, okay, it is like it's stored somewhere like that, because it shows every day's data updated like that only. So is it like
so now you are asking
something
the
is
data sources. You are asking data sources. Data sources is available, madam. You are asking about data sources.
Yeah, yes.
Yeah. So data sources is available, madam. See, we started one work and something. See, you cannot imagine that all of a sudden the sites got blocked. So it was recommended by the government of India. In government of India only, we took that particular site, we entered, and we got some sources of data. They given very clearly. So whatever the reported data, as well as when we are looking at their own data, almost matching. And also they are giving some additional input also. Yes. Yeah. Please, madam, I will tell you. The reason is, so all of a sudden that site got blocked. I don't know what is the reason that. So
yeah, that is what even I was just going through the ministry data site.
Yeah.
And that is I couldn't able to trace certain things again.
Okay, ma'am.
Ministry
Okay.
data.
But we have, madam. We have. But in my, I don't think in my presentation I presented with the data. I will share personally, madam, because I know you. I will share. I don't mind to share with you all. No problem. I will share whatever I'm having the sources. I will share it.
Yeah, thank you, sir.
Yes, ma'am.
It's nice, very informative. That too, people are eagerly waiting for what is information about COVID. We were all eagerly waiting, and you explained so many things. Thank you very much. That was really nice presentation.
Thank you.
Okay, sir. With I think our own colleague, Dr. Sakival sir wants to ask something. With that, I will wind up the chat. I mean, this raise hand option, and I will hand it over to Sir Sundaram sir. Okay, sir. The final from the raise hand side, I will present only Sakival sir. Then I will wind up with this.
Amino only asking in the chat box, sir. Amino.
Hello, sir. Hello.
So I think she joined recently, no?
Can I speak?
Yeah, please, sir. Yeah, please,
sir. Good afternoon, Dr. PonnuRaja, sir.
Sir, thank you, sir.
Nice presentation. I've been watching from the beginning. Meanwhile, I had a call, so I went out for 15 minutes. So a very nice presentation. I congratulate you, sir. And
thank you, sir.
I have a very small basic question. Thing is, a country like ours, our people, even though they have some symptom like fever, headache, cough, or sore throat, something like that, which are the signs of something COVID-like. But our people do not voluntarily go for testing. One thing is testing facility is not available, or they have the fear. So out of which they are not coming forward to the test. And in that sense, the infection rate that we are fixing at a point, maybe not exactly in the reality. It may be underestimate, or sometime it may be overestimate. So is there any other methodology that our country is adopting to evaluate the infection rate, like the case, the article that I have studied in US, they are doing the research, the analysis based on the water that comes out from bathroom and sewage connection. They collect the water samples, and based on the virus presence and the number of people residing in that area, they calculate infection rate like that. Is there any methodology that we are adapting here to evaluate such things? Because people only via testing only we are having the infection rate. So
fine, sir.
Thank you, sir.
Yes, sir. Sir, this is a really interesting question, sir. So whatever we are calculating or not, as well as other parameters, everything is according to the reported data. So the reported data, the previously professor asked, like, sir, if you are extending our testing facility, probably we will have more cases. Obviously, I agree. So there are many reasons that we are unable to extend our facilities hugely, because the cost of the testing procedure is another reason. And of course, we never expect that kind of a pandemic, this kind of outbreak will come to our country. This is even SIRD also problem of having this kind of a disease we started. Otherwise, definitely I never entered with this kind of things. So, sir, is it audible, sir, now? Yeah. Fine. Okay. So, it is everything based on reported data. I am not saying this is kind of overestimate or underestimate, but the estimate which is available according to the reporting sources. If reported is less, my estimate also is kind of it's purely depend on the reported thing. So as such, is there any indirect way to assess? There are many reasons. We don't have kind of facilities. We don't have any kind of facilities, and we never expect this kind of outbreak. One reason. Another reason is, see, you may aware that the corporation people will knock the door and asking your health status, like all are fine or not. So our answer is everybody is doing good. There was no problem. So during that period, if you started with having kind of a thermal infection, identifying temperature. So yesterday I got one news from Madhavaram source that the person, it's a kid, like a 3 years boy, while testing thermal temperature, identified its a higher temperature, abnormal temperature. Then that girl asked to visit the testing facilities, and while we visited there, we tested. Obviously, we got the results like a negative. See, it is not only related to the fever also. So other source says like there are cases positive, but there is no evidence. There is no symptoms. So external symptoms, there is no external symptoms or any kind of um, things to identify easily. Commonly, we used to have kind of a fever or coughing something, sneezing something, whatever it is. And these kind of symptoms is absent, but having diseases, we unable to identify. But unless otherwise, we are making compulsory. This is a serious issue, one thing, but we cannot compel them. Also, if people are ready to forward, if I am ready to forward, one person reported me, they approached one particular hospital in hot places near Chennai. They said, see, you just report to the 108 ambulance, then they will come and pick you up, and they will admit to the hospital somewhere else. Then he tried to call, and the ambulance told, no, 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 you have to refer by, so if you are calling here, you should be referred with some doctors that you are having something like. So who will refer? Then there is no evidence. Then he ultimately, he unable to test for his but he is probably having another symptoms like fever, like coughing, like, but he unable to test, have facilities at the particular center. Then he visited subsequently there, and they identified that he is positive cases. Then later on he went there and he reported some hospital, again they told this is a negative one. So there are controversies over there. So ultimately we need to make a diagnostic procedures common at one places as well as the common at some head, something like, so all hospitals or medical facilities at one roof. So they are the people are the right to diagnose the disease. We want to make it mandate, then we can able to account. So the indirect way, collecting kind of tools or other wastage of toilet, this is really a economical issue, sir, that that we cannot implement even. So in that way, if you are doing that, we can extend our medical facilities ultimately. And people also get volunteered themselves. Some of them are quite honest, they are agree to say I am probably having COVID, but even they are having in their home, they are reporting to the corporation people, everybody is fine. Then there is a problem. So that we cannot see, we have social stigma, sir. So previously the people are afraid of the reason for afraiding COVID is we have a lot of information through kind of a social media, like kind of a panic messages. So we need to see, we could get rid of from that kind of a things. It will take time really, and main reason is economics, sir.
Yes. Thank you, sir.
Yeah, thank you, sir.
Sir Sundaram, sir, you can please take over, sir.
Okay, sir. Thank you, sir. Sir, there are so many participants giving excellent feedback, sir. The presentation is very nice, excellent one, very informative. There are so many participants posted in this chat box. Thank you, sir. Thank you for your informative session. Thank you all, sir.
Thank you, sir. Thank you all. Sir Vishwanathan sir, many thanks sir
Thank you,
for
sir.
inviting me.
Thank you
Very much.
for
Thank you
sharing
for
your experience
presidency
and
team.
knowledge.
No, sir, thank you sir. Thank you very much sir.
Now, Jayashree madam will.
Yes, sir.
Yes, ma'am.
Am I audible?
Yes madam. Please.
Professor PonnuRaja sir,
Yes ma'am.
you have definitely enlightened us with the compartment model, that is said compartment model about COVID-19 and which is the order of the day. And I thank personally and on behalf of the department for sparing your valuable time with us.
Thank you.
I invite Professor Radha to propose vote of thanks.
Hello. Hello.
Yes madam.
On behalf of everyone, on behalf of the head faculty and research scholars of Presidency College, I take the privilege in thanking you for your informative session, sir. And during this COVID-19,
Thank you very much.
your session was more informative, and especially the compartment you have discussed in SIRT model, and you have given many suggestions and also the ways for the upcoming research scholars to do research work. And you were very patient in answering all the questions. I think some more, even some more have their thing, but due to the time permit, we cannot proceed, sir. But anyway, thank you. And I also thank the IQAC team in extending the cooperation for this platform. Once again, I thank Dr. PonnuRaja sir for being with us. Thank you, sir.
Thank you, madam. Thank you very much.
Sir, organizing secretary Srinivasan sir.
Yes, sir. Yes, sir. With this, we can conclude this particular session, and we will proceed with 3 o'clock or 2:30 advance. In advance, we can start launching the things. So session starts by 3 o'clock.
Okay. So we will allow the participant from 2:30.
2:30. Okay, Professor. Thank you very much. Thank you.
Thank you, sir. Thank you, sir. Thank you very much.